So the future work, we want to measure the torque load to suitable the engine. I think it's enough. Thank you, sir.
Thank you, Pak. Yeah.
Yes.
Okay. So we still have around 4 minutes again. So if anybody has question, please just raise your hand, or you can also directly give me a sign.
Yes, sir. Before any question, I want to say we want to invite to the researcher in here. If you have a problem research about design machine, we want to join to research with the. You can contact the Dr. Ramayanti Bulan or me, Dr. Ramayanti Bulan in Unsia, me and Indonesian Institute of Science in the Java. So if you want to join research about design machine, we can do it together. Okay, sir.
Okay, so that's kind of an invitation. So anybody, if you have a problem or you wanna do something together, just contact Pak Agustami Sitorus. Okay.
Yes, like that.
Okay, one question, please. One question. No question? Okay, so I'll give you one question. you know that one job for the moderator is for to give question. Okay, so I want to ask you about the requirement for the OPF. Is there any specific requirement for the OPF? Should the OPF be fresh, for instance, or can it be dry? Because I don't know the design of your chopper. So let's say if I have a dry OPF, can I use yours?
Yes. It's a relation about the functional UVF. If you want to fit, we must be a fresh OPF.
Okay.
But if you want to make a material like a particle board, maybe if you before they chop it, we want to dry the chop it.
Dry it first.
I think
okay.
It's related to the functional the UVF.
Okay. Okay. Thank you. Okay. Now,
thank you, sir.
Okay. Now time is up, and then we should move. Thank you for the nice presentation. We should move to the next topics. I invite Bagas Budi and Anazur Rizal for presenting their work entitled Developing Agricultural Sectors Outputs, Empirical Study on West Java Province, Regency, and Municipality. Please, Bagas Budi and Anazur Rizal, you can share your screen directly and present your works. Time is yours. Bagas Budi and Nasrul Rizal, are you here? Any problem with your connection maybe? No? I received some info from the committee that not all the participants written in my notes, in my PDF files, attending this presentation session. So if I call you, let's say 1 or 3 times more, and then you don't give me sign, so I will just go to the next presenter. Bagas Budi or Nazrul Rizal? It's not here. Okay, then I will just continue to the next presenters, Muhammad Fahri Reza Pahlawan, Rina Kusumawati, and Rudiati Evi Masito. Please present your works with the titles of Development of a Low-Cost Modular Spectroscopy for Predicting Soluble Solid Contents of Banana. Time is yours. You can directly share and present your works.
Okay, thank you for the time. Hello, my name is Muhammad Faireza Palawan, and I will present my team research paper with the title of Development of a Low-Cost Modular Fish and IR Spectroscopy for Predicting Soluble Solid Content in Banana. Banana is one of the most popular fruit in the world. Due to its popularity and high demand, it is important to produce high quality of banana. And one of the most important parameter of banana is soluble solid content. Commonly, soluble solid content can be determined using refractometer, but this method is considering as destructive method because the sample must be destructed before assessed. Unlike refractometer, non-destructive method to assess soluble solid content in fruit using visible and near-infrared spectroscopy has been reported. Fish and IR spectroscopy is a type of spectroscopy that has region range between 400 until 1000 nanometer. Compared to other NIR spectroscopy, it has cheaper price, stronger penetration energy, and lower heating. Fish NIR spectroscopy can record the amount of energy that absorbed, reflected, or transmitted by the molecule of sugar in based on third and fourth overtone of vibration. This low cost spectroscopy offer rapid analysis, limited preparation, and non-destructive measurement of soluble solid content. Chemometric analysis with partially square regression combined with reprocessing technique were commonly used to build calibration model that can convert the spectra into predicted soluble solid content for unknown banana samples. Many studies have been conducted using fish and IR spectroscopy to predict soluble solid content in fruit, but the performance efficiency is still under study, especially in the base probe sample distance, which provide the best prediction. Therefore, this study was aimed to examine the potential of modular and low-cost fish and IR spectroscopy in predicting soluble solid content in bananas by varying probe and sample distance. The sample used in the study were 200 of banana from two kinds of banana variety. To obtain soluble solid content variation, the banana was stored at room temperature up to 3 days, 30 to up to 40 bananas were assessed per day. The sample analyzed using SNEL and IR spectrometer by ocean optic with tungsten halogen light, and reflectance spectra were collected using ocean view software. A black chamber was used to image acquisition to minimize outside light. The distance between the probe and sample were adjusted using movable layer. 3 sample distance were used in the study were 0, 1 cm, and 2 cm. Soluble solid content measurement were done using digital refractometer by HANA instrument. From the analysis spectra, soluble solid content and spectra were imported into unscrambled expression software, and then all spectra were divided into calibration set and prediction set. Calibration set were used to build the calibration model, and prediction set were used to test the performance of the model. This table shows the static summary of this soluble solid content values. This figure and the figure show the average spectra of banana captured in the range between wavelength 450 until 1000 nanometer. All samples were divided into 3 groups based on soluble solid content value. If you can see, there was a high reflectance, a high reference peak at around 500 nanometer that correlated with carotenoid, and there was peak at 675 nanometer which correlated with chlorophyll, and there was and at around 720 there was peak which correlated with third overtone and of CH stretching or second overtone of water bonding. The chlorophyll spectra might be correlated with ripening process during ripening process, chlorophyll content will decrease and soluble solid content will increase. Chlorophyll content might be inversely correlated with soluble solid content, and at 675, the lowest reflectance were found by the average of highest soluble solid content group of bananas. This table shows the performance of calibration and prediction of partially correlation for soluble solid content values. The best R square, lowest R square were obtained from standard normal variate preprocessing spectra with 2 cm distance between probe and sample. The high R square can be obtained because this instrument was weakly absorbed water content, which are the largest values component in the fruit. This figure shows the average of R square C and R square P. From this figure, we can see that adding more distance between probe and sample can improve the PLS model performance for calibration for soluble solid content calibration and the prediction model. This figure shows the regression coefficient of PLSR using SNV spectra with 2 cm of the probe sample distance. In this figure, we can see that the spectra were highly damaged, but the several peaks can be noticed, which previously reported correlated with carotenoid, chlorophyll, and water.
Sir.
Soluble solid content could be correlated with chlorophyll content in the peak around 675, but it is still unclear which wavelength that contributed the most to determining the soluble solid content values. And in the conclusion, the soluble solid content of banana were measured with fish and air spectrometer at wavelength 450 until 950 nanometer. Several preprocessing spectra were used on the 0, 1, and 2 distance of detector sample were evaluated. The best calibration model for soluble solid content resulted in R square C of 0.96 and RMSEC of 1.15 obtained from SNV preprocessing spectra with 2 cm distance. With proper selection of chemometric and sample detector distance, this instrument is promising tool to measure soluble solid content. Okay, thank you.
Okay, thank you for Pak Reza Pahlawan for very nice presentations. So now actually your time is about to finish. Only 1-2 minutes left. Anybody has question for him? Okay, for Pak Agus Sitorus, please.
Yes, thank you. Nice presentation. I don't know the name, the authors, but I want to know about what the type the fish snare you using. You develop or using the fish snare standard fish snare. Thank you.
Actually, this is our new instrument in our laboratorium. We use modular fish snare spectroscopy. It has cheaper price at around maybe $100 million compared to near spectrometer, and this is the instrument I use for this paper.
Okay, you using a standard. I think you develop the Mr. Fish snare. Okay, thank you.
Yeah. Okay. So I think Mr. Reza Pahlawan, I think he just used the one bought from the big company. Okay. Okay, thank you. So time is up. So please give him applause. That's very interesting topics. Now we only have 2 presenters left. I will invite Miss or Mrs. Faida Rahmi with the title of her presentation is a mini review on characteristics of the big fish or Rasbora tawarensis and its processed products. Please time is yours, and now you can present your work directly.
Thanks for giving me this opportunity, Mr. Arifin. Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. Good day, ladies and gentlemen. Let me introduce myself. My name is Faida Rahmi. I am lecturer in Department Aquaculture Gajah Putih University, Central Aceh. What I would like to talk today is to explain a paper, a mini review on characteristic of the big fish Rasbora taurensis and its processed products. Introduction. The big fish, or Rasbora taurensis, is a typical endemic freshwater fish of Laut Tawar Lake in Central Aceh. Due to several reasons, the big fish population is currently decreasing drastically. Even the big fish has been appointed as a fish with a threatened status. Studies on the existence of the big fish as local food, form of presentation, and nutrition. This article attempts to review the existence of the big fish and its processed product through several existing studies. According to Weber, the big fish classification belongs to the Crypinidae family and the Rasbora genus. The Rasbora clan is known as a genuine freshwater inhabitant, living in small rivers at the foot of mountains, lakes, and swamps. The complete classification of the big fish is as follows, like a picture. Distribution, morphology, and genetic characteristic of fish, the pig. The pig can be caught throughout the year. However, there are times when the pig fish rise to the surface or appear in large number. In the Guyanese, namely the peak season. The peak fish season occurs in months with high rainfall ranging from April to June and October to December. In the peak season, there is a natural symptom, such as the wind blows colder with drizzling rain. Guyanese said, "Kuyu ni the pig." And this is process of the big fish product. Fresh the big fish can processing to pengat, dedah, masam jing, the big tangkap, and pepes. This is a traditional food dish. Other processing is the pig fish, dried the pig, or fermentation, the namely belacan the pig. This is like the picture, fresh the pig fish, dried the pig, and belacan the pig. Chemical and microbiologic characteristic of belacan the pig. Characteristic: moisture, protein, fat, ash, pH, and lactic acid bacteria. Conclusion: the pig fish is a typical endemic fish of Laut Tawar Lake, belonging to the Crypinidae family and the Rasbora genus. The fish population is currently decreasing and it is designed as a fish with a threatened status. However, the people preference for this fish remain high both in fresh and processing product, namely dry depik and belacan depik. The characteristic of belacan depik obtained from market in Takengon City have moisture content of 58.2030, more or less 1.26%. Protein 60.25, more or less 1.30%. Fat 4.24, more or less 1.25%. So thank you.
I'm sorry, Mr. Arifin, you are still in mute.
Okay, sorry. That's a nice presentation. So this work is kind of a review paper. So we can see a lot of information from Miss Farida Rahmi. That's very nice. Now I would like to invite question from you. Anybody?
I have a question.
Okay, so Miss Elvira, please.
Okay, thank you, Faida from Gajah Putih University. Yeah, this is Kandepik. This is a very local indigenous product from Aceh Tengah. Yeah, from Takengon. Yeah, thank you for the information. But can you more explain, or do you have any information about why it tend to be decreased the population of ikan depik in Takengon? Is it belong to environment, global warming, or there is any special condition that ikan depik needs to live? So we can eat ikan depik for more 100 years maybe. Okay, thank you.
Can I speak Indonesia?
Indonesia? Okay, okay. Mr. Arifin, can I translate it to Indonesia?
Yeah. Okay, you can.
Ya, ini ikan depik ini kan sangat spesifik lokal ya untuk Aceh Tengah. Tapi kan tendensinya terus menurun nih populasi ikan depiknya. Ada informasi nggak kenapa ini decrease, menurun? Apakah karena ada isu lingkungan, global warming, atau memang ada keadaan lingkungan spesifik yang dibutuhkan oleh ikan depik? Jadi mereka bisa continue, bisa kita makan selamanya lah sehingga tidak punah begitu.
Faktor cuaca saya rasa berpengaruh. Apalagi kan kalau tadi kan musim depik itu di Takengon sendiri bulan Juni sampai dengan bulan April sampai dengan bulan Juni dan Oktober sampai Desember. Nah di saat itu memang tidak seperti biasanya. Kalau ikan depik kan biasanya banyak gitu kan. Hanya kali ini memang salah satunya faktor lingkungan berpengaruh juga karena memang sungai dan danau Laut Tawar itu sudah terkontaminasi oleh sampah dan memang sampah yang di danau Laut Tawar itu juga tidak bisa diurai ya Kak Elvira ya. Jadi mungkin menurut saya berpengaruh dari faktor lingkungan.
Cultivated.
Itu saja. Saya kembalikan ke Pak Arifin.
Okay, thank you, Faida. Good job.
Thank you. Good job. Okay. Okay. Actually, time is up, but I have question. Can you please go to the slide number 8? Slide nomor 8.
Oh, nomor 8 ya?
Yes. Okay. 20. If we sum the sum of the proportion, say okay, let's say moisture 58 we add 16 and then fat 4%, so it will be around 20, 78, and then we put ash 78, and then will be at 90% only. So if we sum number 1 to number 4, because that's in percentage, that's only 90%. My question is, what the rest 10% is?
Boleh berbahasa Indonesia, Pak?
Boleh, boleh. Jadi ini kan ada, ini kalau kita lihat dari 1 sampai berapa? Sampai 4, itu kan totalnya hanya 90%.
Ya.
Nah, yang 10% itu apa? Kan pasti kalau kita bicara proporsi 100, selalu 100% gitu. Nah, ini kok hanya 90. Nah, 10-nya lari kemana, Bu? Gitu.
Iya ya, Pak ya.
Iya. Silakan Ibu tambah itu hanya 90 itu.
Saya justru nggak ngitung.
Oh, saya yang ngitung Bu ini ya Bu ya. Ya nanti tolong mungkin bisa dilengkapi ya Bu ya, karena kalau kita bicara presentase kan 10 mungkin ini siapa tahu ada dari fiber mungkin ya, fiber mungkin atau komponen yang lain kita tidak mungkin air sudah ya gitu. Oke, gitu ya Bu ya. Berarti ya, Ibu Pak juga belum tahu ya gitu ya. Oke.
Ya belum tahu karena memang sedang dilakukan penelitian juga, Pak.
Oke ya. Tapi ini harus 100 gitu ya.
Oke, Pak,
Bu,
ya.
makasih ya, menarik sekali ya. Oke, now time is already 12:38. Now we have to move to the last presenters. I will directly invite Miss Astri Widyasanti, Sarifah Nurjana, and
excuse me, sir.
Yes.
It's time to break. I'm so sorry.
Okay.
Because in Aceh it's time for duhur.
Okay.
So okay, we can take a break for a few minutes.
For how many minutes?
I'm so sorry. Take a minute for I asked to commit.
Okay, yeah. So I will wait for your information then.
Okay, sir.
Yeah.
We have a break until 1:30 p.m.
1:30 p.m. Okay. And then how about the last presenter?
We can continue it later.
Okay, so we will continue with the last presenters in the first session later after 1:30 p.m., right?
Yes. Yes, sir.
Okay, yeah. So everybody understand about this, right? The participants? Okay, so yeah, okay. So the last presenters will present their works after 1:30 p.m. Okay, so now I will give times to the co-host. Maybe you can move all the participants to the main room. Thank you.
Yeah, thank you for the moderator. I'm so sorry for all participants and all presenter. We can back until 1:30 p.m. and wait for a minute to back to main room. And please click leave room to back to our main room for a few minutes so we can wait it together.
Okay.
Thank you for everyone.
Yes. Yeah. To finish it. All right. Okay. 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 So yes, yes, that's very clear. I think it's better to continue because I think the last presenter is not from Aceh but from West Java, I guess. Is it correct? I will. I will just ask Miss Asri Widyasanti or Miss Sarifah Nurjana or Mr. Bambang Nur Hardi. Do you hear me? Do you hear me? Miss Asri Widyasanti or Miss Sarifah Nurjana or Mr. Bambang Nur Hardi. Do you hear me? I think that's from Universitas Pajajaran, if I'm not mistaken. Yeah.
I'm sorry, but we have some participants that already moved to to main room.
Okay.
Not only certain participants. I think some participants have been moved. Maybe we can take it.
Okay. Or maybe if you, yeah. 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 Okay. Yeah. Waiting for you. Yes. Yeah. The Asri Widyasanti, yeah, Asri Widyas Sarifah Nurjana or Bambang Nur Hadi. Yeah, because the names mentioned in my paper are all the authors, not only one. Okay, all the, yeah. I don't know exactly who will present their works. Asri Widyasanti, Sarifah Nurjana, and Bambang Nur Hadi. Yeah. Okay, welcome. Ya. Pak Bambang Nur Hadi tidak hadir ya sepertinya. Oke. Oke, kalau gitu berarti ini bisa dianggap selesai saja sesi pertama gitu ya Pak ya berarti. Oke. Ya, seperti itu saja sepertinya. Berarti ini peserta yang lain asumsinya sudah off ya Pak ya. Ini berarti mungkin saya bisa off dulu sementara gitu. Oke, ya. Ya, makasih Pak. Semangat.
Good morning, Professor.
Good morning, Rita. How are you?
I'm fine, thank you. And you? We get as Eden?
Yeah, I'm fine too, thank you. So you can hear and see me without technical problems? Wonderful.
Yeah, I can hear for your voice clearly.
Okay, that's very good. So when we start, you will introduce me or should I introduce myself?
Yes, I will introduce you and then you come directly to the presentation.
Okay. And I know how to operate.
Okay. But we will wait some more minutes, please, Prof.
No problem. I just wanted to know if the technical background is working correctly. Yes. Fine. Then I will wait.
The conference already 6 hours ago.
Okay.
Yes.
So everything is fine.
Yeah. The problem is of course with the internet connection. Because the weather is also not so good in Banda Aceh. We have rain and strong winds.
Yeah.
Yeah, but until now, the electricity is okay.
Okay.
I hope because it is very important for us to have electricity.
Yeah. We hope the best.
I mean.
Okay, then I will wait for another 10 minutes and then we start.
Okay.
Thank you.
We are waiting for Dr. Amro also, Dr. Hassan.
Yeah.
Amro Hassan.
Okay.
Oh yeah, Professor, did you receive what we sent to you?
Maybe, I don't know yet because I'm not in the office today. I'm working from home because I have a better connection here.
Yeah, me too. I work from home.
Yeah. So I guess it will be in the office by now.
Yeah.
Thank you very much for that.
Yeah, you are welcome.
There's also the problem that in the office, I'm not allowed to use Zoom.
Okay. Okay.
Because it's a question of data policy, because the server of Zoom is not in Europe, it's in United States, and that's the reason why we are not allowed to use Zoom at work normally. So I'm doing it from my home office.
Did you try to use like our virtual backgrounds from homes?
I tried it, but since I have not installed the app of Zoom, I'm not able to put it in because this option is not offered in the browser-based solution. So I'm sorry for that. You have to look on my ceiling.
Okay. No, it is not a big problem, and no problem actually.
Okay.
No. And you know
it's a one-day club. Yeah.
Yes, bro.
Go ahead.
You know, in Banda Aceh, at the moment, the increase of the the person who infected by COVID-19 at the moment is in the peak position, I think.
Okay.
Yeah. So, yeah, actually, we it is not a new normal for us. You see, we have different condition.
Yeah. In Germany, the numbers are climbing again.
Okay.
We have about 1,800 to 2,000 infections per day because all the people are coming back from their holidays.
So then, like the door is open for the virus.
Yep.
The holiday.
One more technical question. When we start, should I open up my presentation immediately?
Yes, Prof. You can open your own your presentation. Maybe that is better for you comfortable. Yes.
Okay.
I
will
tried to study that. I read maybe 3 times.
Yeah.
For myself, yeah.
Okay, I'm trying to share it.
Yeah,
Can you see it?
very nice. Yeah.
Okay. Wonderful. Then I hope everything will go fine.
Yeah, I hope so.
I have to admit, this is my first digital presentation on a conference, so I'm a little nervous.
Okay, really? Okay. Yeah, hello? Okay, you start to record. Please.
Okay, Rita, you are telling me when I have to start. Okay?
Okay, so I will stop your sharing first, Professor. And later on, please share again, okay?
I didn't get that. What?
I stop your screen already for a moment, but later on, you can share again.
Okay.
Okay. Because they inform me that the MC is ready now to open.
Okay.
Thank you very much for the time, Mr. Juzaili Ridwan and Miss Anna Misko. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good afternoon, and special for our professor. Good morning, guten Morgen.
Good morning.
So, it is an honor for me to be a moderator for our session, for our discussion session. Yeah? And to introduce myself, my name is Rita Khotir. I graduate from Agricultural Engineering Department, Faculty of Agriculture, Universitas Syah Kuala. And then I graduate my master and my PhD from German University, George August Universität Göttingen. And now I'm working as a lecturer at my alma mater. Okay, and now we want to welcome our professor, Professor Jens Karl Wegener. He comes far away virtually from Germany. You know that the distance between Banda Aceh and Germany is about 9,000 kilometers. And now we can see our professor directly, of course, but virtually. Let me introduce you all about our professor. At the moment, our professor is a head of Institute for Application Technique in Plant Protection of Julius Kunst Institute, JKI. He is also a head of Advisory Committee for JKI approval of plant protection equipment, JKI Fachbeirat, Geräte, Anerkennung Verfahren. And he is also a head of meeting for Fachreferenten für Anwendungstechnik. Professor is also a member of German Phytomedical Society, DPG, member of NORM Group for Agricultural Engineering, and member of VDE-MEC Expert Committee, Research and Teaching. He is involved as editorial board of the journal Landtechnik, Agricultural Engineering, and the Journal of Cultivated Plants. His major in plant protection and animal health, horticulture, and environmental sciences, with expertise in production, risk assessment, greenhouse gas emission, fuel cells, biogas, pesticide application, and shipping of wood technology. And now, we will listen to our keynote speaker, Professor Jens Carl Wegener, with the topic of sport farming giving sustainable intensification a face. Professor, the floor is yours.
Thank you very much, Rita. Good afternoon, ladies and gentlemen. I will start sharing my screen. Can you see the presentation?
Yes, Prof. It is very clear.
Wonderful.
Very clear.
Then I will start. Dear audience, dear ladies and gentlemen, it's a great pleasure for me to give a presentation on the International Conference on Agricultural Technology, Engineering and Environmental Science 2020. Many thanks to the organizers inviting me and giving me the possibility of presenting our research. My name, as already stated, is Jens Carl Wegener, and I'm the head of the Institute for Application Techniques in Plant Protection at the Julius Institute, which is a federal research center for cultivated plants in Germany. The title of my presentation is Spot Farming, Giving Sustainable Intensification a Face. Within the next 30 minutes, I will share our ideas how we can maintain or even increase yield by reducing the input of resources at the same time. Doing this in a sustainable way seems like trying the impossible, but up to now, we are convinced that we can achieve the goal. From 2015 to the end of 2017, 3 German research centers located in Braunschweig, Germany, together worked on a project called With Autonomous Agricultural Machinery Towards New Cropping Systems. Aim of the project was to derive different possible scenarios for future agricultural systems for plant production under German conditions. Background for this are new developments in terms of digitalization, automation, big data approaches, autonomous tractors, etc. The derived scenarios should be assessed from an economical, technical, and agricultural point of view afterwards. Out of a number of different scenarios, we developed 2 based on autonomous field robots. Both differ concerning the size of the robot concepts. We had a large size concept based on autonomous tractor systems and a small sized concept based on field robots. Today's presentation will focus only on the small scale robot scenario. Reason for that is that at some point of the project, we realized that the changes we wanted to achieve towards new cropping systems are not possible with established machinery. Hello?
Yes.
Can you hear me?
Yes,
Yes,
you, Professor. I'm sorry.
Okay. I come back to the presentation.
Yes, please.
Out of a number of scenarios we developed, 2 based on autonomous field robots, and both differ concerning the size of the robot concept. We focused on the small scale concept because we realized that the changes we wanted to achieve towards new cropping systems are not possible with established machinery. Moreover, to reach the goal of developing new cropping systems, we were convinced that we had to ignore technical development completely at the beginning, just focusing on the needs of cultural plants. The project was also driven by today's challenges we are facing in agriculture all over the world. We have growing population worldwide, we have to feed, we have degradation of arable land, climate change, foreseeable shortage of resources, and many more. These problems have to be solved in a socially acceptable way. This becomes more and more difficult in our days against the background of a society where a majority of people have no more idea how their food is produced and where it even comes from. In Germany, as in many other countries with industrialized agricultural production systems, we are in a crisis. We are facing a lot of concerns and problems addressed in public discussions towards the farmers. People in general are concerned because in their eyes, farmers contaminate the drinking water with nitrates, they are poisoning food and feed with pesticides, they torture livestock animals, they ruin the health using green gene technologies, they devastate the landscape by seeding monocultures, they make people scary with their big machinery in traffic, they increase the energy costs by building socially funded bioenergy production capacities, they are all subsidized by society due to public funding, and moreover, they produce a lot of greenhouse gases, suffering from climate change at the same time. Even though I do not share all of these arguments completely, and even though they are pointed out, to some extent, a few of them are based on real problems. For this reason, proceeding agriculture in a way we have done in the past is no future strategy. Change is strictly needed. Before starting a project such as developing new cropping systems, one has to define the goal. In our case, the goal is sustainable intensification. What is the idea of sustainable intensification? It is to increase the output while decreasing the input at the same time. The graph shows an agricultural production function. You can see it here. Yield is increasing with increasing use of resources, such as water, nutrients, and pesticides, for example. This is the common strategy of agriculture in the past. With this strategy, one moves from point 1 to point 2 on the graph. But with climbing resources, the gain in yield, which you can see here, is decreasing. So at some point, it makes no more sense to raise the input. To move towards higher yield without raising the input, as you can see in point 3, or even by reducing it, point 4, we need another production function. And this can be achieved, for example, by different innovations. But additionally, in order to increase public acceptance for agriculture, various secondary objectives have to be respected. For example, the enhancement of ecosystem services provided by agriculture, such as biodiversity or linking of habitats and diversified landscapes. The question is how we can reach the goal of sustainable intensification with simultaneous consideration of social demands. In the past, I'm convinced that agricultural machinery defined the framework for plant production systems. Today, we need a change of perspective. We need to focus on the plants. In order to do so, this mentioned change of perspective is necessary. To increase yield, fundamental requirements of crops have to be satisfied. Cultivated crops have to fit to the location where they are planted, and functional elements of landscape, such as hedges, ditches, and wildflower areas, have to protect the cultivated crops. These three different levels, single plant level, field level, and landscape level, have to be considered. On single plant level, we need to fulfill the basic requirements of cultivated plants, as you can see here. They need sufficient light, space above and beneath ground level, water, unspoiled soils, nutrients, healthy and wide range crop rotations, and plant protection. On field level, we have a general need for the reduction of agrochemicals, such as fertilizers and pesticides. The soils should be protected against heavy loaded crossings, especially with high wheel loads, and we also need a better consideration of small-scale climatic conditions. Concerning the landscape, we have to develop structures being harmonized to natural, geographic, and climatic circumstances. They should protect the crops against wind and soil erosion, as well as transfer of agrochemicals to non-target areas. Refuge and buffer zones can help to interconnect different habitats in order to increase ecosystem services of agricultural landscape. Smaller structures leading automatically to higher diversification of landscapes can also help to gain back public acceptance. So the new cropping system we are looking for should combine all these requirements and restrictions on the three stated level to reach the goal. And this is a non-trivial challenge. So the big question is how we can reach this goal. Before I start to present our solution, I will state another 4 hypotheses which are of main importance to find the right cropping system. First, we need to improve the allocation of cultivated crops to suitable locations. I will give you a simple example. A wine grower would not have the idea to plant his vineyard on the north side of a hill. It just does not fit under consideration of yield, quality, and taste of the product. In the broadest sense, this is exactly what we are doing with a lot of cash crops in some regions. They are planted in locations where they just do not fit to the available natural resources. But with help of fertilizers, pesticides, and drainage or artificial water supply, they are forced to grow and produce yield. And I think that this is not a very sustainable way of producing food and feed in a long-term view. Second, the management of natural resources such as water, light, and soils has to be optimized in terms of spatial and temporal utilization. One example, in Germany, we are growing sugar beets to produce sugar. And if those sugar beets are seeded just a few days earlier, one has a significant impact on yield. There are different reasons why this is always and everywhere possible. For example, climatic reasons like danger of late frost periods in certain areas, but there are also reasons concerning the trafficability of the fields. If they are too wet, big tractors used in our days cannot seed the beets without damaging the soil. And if we would have lighter techniques, they could be planted earlier and we could increase yield by doing this. Another example, the natural offer of sunlight on a certain area is given, and we cannot influence that. What we can influence is the architecture of the plants growing on that certain area. If two crop varieties with different heights and different leaf orientation are combined, the efficiency of photosynthesis per square meter can be improved. We also can improve the distribution and stand density of the plants in order to increase yield. Third, we need to improve the efficiency of agrochemical utilization. Today, we are doing a lot of research on site-specific treatment of plants, for example, with fertilizers or with pesticides. And first applications are in agricultural practice. In future, I'm convinced we have to go ahead and we need a single plant treatment. Fourth, the general structure of our landscape has to be changed towards smaller elements, more structure and diversity. We need to re-implement functional elements such as hedges, ditches, and spots of grassland with bloomers, because they fulfill some of those ecosystem services we are lacking of. So in many cases, the characteristics of agricultural fields are not homogeneous all over the field, concerning, for example, soil type, yield, water supply, altitude profile, geographic orientation, potential of erosion, etc. But by superimposition of these individual characteristics, one can derive spots of nearly same properties. These spots, being homogeneous to the greatest possible extent, can be cultivated independently from each other. And this is what we call spot farming. I will give you a simple example below. On the left side, you can see an aerial image of a field. And due to the different colors of green you can see, one can already imagine that this field is not homogeneous in its properties. And under consideration of information, in this case, a very simple example, we only consider two information about yield and soil type. We can derive homogeneous spots, as you can see on the pictures on the right side. And these homogeneous spots are homogeneous to the greatest possible extent. And how can we use this information? Actually, such field maps could be used for site-specific treatment, such as working with different seed densities per spot, for example, or for different fertilizer or pesticide strategies. In our approach, we go a step further. We want to have different crop rotations on each spot, which are fitting the best to the properties of each individual spot, what you can see on the right side. Another idea and part of the system to reach sustainable intensification is to optimize the crop spacing. In a triangular seeding pattern, which you can see on the left side, each individual plant has maximum spacing above and beneath ground level. And this also goes along with the maximum of irradiation by the sun. In a triangular seeding pattern, the number of seeds needed per square meter is much lower compared to a row seeding pattern. It's approximately a little more than half as much as compared to the row seeding pattern. This automatically leads to a reduction of seeds as well as seed dressings needed. Thinner seed patterns can have phytosanitary advantages, and each single plant can be more competitive. This can also lead to a reduction of pesticides needed, and it's an interesting question we are just doing research about within the last 3 years. Another point is, and that's a technical point, that one can drive through a triangular seeding pattern in 3 different directions. And nowadays, mechanical techniques come back into the market because society does not want to have chemical treatments. So this can be an important advantage because the weeds standing within the intra-row section can be weeded without complex and cost-expensive sensing and computer-steered systems for detecting and eliminating the weeds. It can work very simple. But this requires georeference seeding technologies with high precision concerning seed deposition, also in relation to the depth for more uniform sprouting of the cultural plants. And this is something we are lacking of at the moment, and where we have built a prototype for our research so far. Triangular seeding patterns also have an impact on the aim of plant breeding. Today, genetic resources are most often invested into tolerance and resistance of cultivated plants against diseases, which normally goes along with decreasing yield. Our hypothesis is if a new cropping system can help to strengthen natural defense mechanism of cultivated crops and at the same time can lower the phytosanitary pressure, then we can shift genetic resources towards yield. The problem up to now is that no one by now knows which characteristics of different cultivated plants are the most advantageous in a triangular seeding pattern. The focus of breeding was on row seeding patterns in the past. And this is a question we are just trying to find out for different grains. Talking about fertilization and plant protection, we have to come to demand-driven solutions on single plant level, as already stated, in order to optimize the input of resources. This goes along with an early identification of plant diseases, pests, and nutrition demand, done by constant monitoring. Once demand is recognized, fertilizer and pesticides have to be deposited in a way that they are completely absorbed by the cultivated plants. And this requires high definition information as well as techniques for precise deposition of fertilizers above and underneath ground level, respectively, for the precise application of plant protection products. Up to now, I have upraised a lot of requirements, and maybe some of you are already concerned about the question how this can be realized. I think it does not need a lot of fantasy to imagine that today's agricultural machinery is improper to work on small and amorphous spots, as you have seen before. For this reason, after having derived ideas for new cropping systems by ignoring technology, now we have to focus on technology. And in our eyes, small autonomous robots working in swarms, performing different processes while coordinating themselves, could be a suitable technique for new cropping systems as presented. The low performance capability of a single robot can be compensated by the number of robots being used. Theoretically, robots have an operational readiness of 24 hours at 7 days a week. Robots waiting only a fraction compared to a modern tractor, they have much larger processing windows concerning soil protection and trafficability of soils. These properties can help to improve the overall performance capability of small autonomous machinery. Moreover, the presented spot farming system raises yield by optimizing crop allocation as well as local field management. Even those processes being managed by very large size machinery, such as combined harvesters, can be managed with small robots also. If the combined processes, like in this example, cutting, collecting, flailing, chopping, and spreading, are dissolved again, then we can do the process also with autonomous small-scale robots. In our project, we wanted to know if a process chain with small autonomous robots generally is able to do all annually work in cropping from a technical and economical point of view. In order to check, we choose a scenario of a production of wheat on 150 hectares in a crop rotation with corn. For this scenario, we defined different requirements, which you can see on this slide. The requirements are a tillage with a working depth of at least 20 centimeters, a precise deposition of 150 to 200 seeds per square meter, the application of fertilizer and plant protection products to single plants, and a processing and transport of 20 tons of material per hectare during harvest. When we started our project in 2015, only few robots were used, mostly in scientific projects. Today, first solutions have appeared on the market and farmers can buy those systems. They differ in design, concept, and size, and most of them are only applicable for one type of working process. But there are still big challenges concerning the practical utilization of autonomous field robots. What is the optimal concept, modularity, and size of a field robot? How do they work under practical conditions? How safe and reliable is the autonomy of the working process? What safety requirements do we need for practical use? Which solution is best for energy supply and what infrastructure is therefore needed? Those are all questions we cannot answer yet. And in our theoretic approach, we did not focus on these questions, although they are very important. What we have is with different robots concepts designed by students from the Technical University of Braunschweig. We had different concepts for different purposes, and they were designed with the help of a CAD program. And here you can see 5 robots being chosen at the end. The number of robots being necessary to produce wheat on 150 hectares is depending on area efficiency of the concept and provided field working days. In the table, you can see the number of robots needed based on this approach. And the number is also depending on the size of the robot. The ones on the left side are bigger ones, and the one on the right side are rather small robots. In the next step, the cost of each robot concept was calculated under consideration of all elements known from the 3D models within the CAD program. And from this information, at the end, the operating costs were calculated, derived from numbers and cost per robot. These operating costs are shown in the table, and they are compared to average operating costs of today's machinery in Germany from literature. And what you can see is that the operating costs of a robot scenario is or can be competitive. And this is the main outcome of our research project. But we still have to admit that this scenario is just a rough estimation. And as I already mentioned, there are tons of questions concerning the feasibility of robot concept in practice. But the general approach seems to be at least an option worthy to think about for future. And moreover, the scenario we use, the cultivation of wheat, is compared to other cultural plants such as root crops or vegetables, much more challenging in the processes we have to deal with. And at the moment, on the German market, we can see that there are quite a lot of companies entering the market with robot systems being sold to farmers for certain purposes. And the prices for the robots are quite comparable to what we have calculated for the big ones on the left side. So we are not too far from reality with our approach. So let me come to the conclusions. What we found out with our approach is that sustainable intensification can be possible, even with regard to socially demanded restrictions, if we focus on new cropping systems. The machinery needed for new cropping systems are probably small autonomous robots, which are basically able to manage any agricultural process and whose operational costs are comparable to modern machinery. Autonomous robots are under development in science and companies, and first concepts, as already mentioned, have entered the market by now. And those autonomous robot systems have a lot of advantages. They can replace labor not being available anymore at the market. In Germany, for example, if you have to weed your sugar beets by hand, you don't find any people who would like to do that. also during harvest in vegetable or fruit production, farmers can hardly find any workers anymore doing that. Robot swarms can lower the risk of machine breakdown, because if you have a robot swarm with a number of robots and one machine is breaking down, the other ones will still work on. They have advantage abilities for new cropping systems, which I've showed to you, like the spot farming concept. And also interesting due to the low cost concept and the autonomous mode of operation, they can also be a solution for small scale farmers. In Germany, we have quite a large number of farmers who are not farming, which is not their main job. They work in a job and they, let's say, have like 10, 20 or 30 hectares of land, and they do the farming at the evening. And for those small farmers, this can be also an advantage if we have autonomous robot concepts helping them to give their small farms a future. Okay, at the end, I would like to thank my colleagues for the joint research project and you, the audience, for your kind attention.
Thank you very much, Professor. Yeah, you did a very nice presentation, and your time is very precise. Thank you very much. And you know, for our discussion, we already invite the participant to give you some questions. But due to the limited time, we ask them to write down the question. So now I have some question with me. I will share to you. This one, Professor. For the first discussion, we have three questions. The first one is from MISTI. The institution is ERRD. And the question is how we can effectively this innovation dissemination to increase cropping index due to the pandemic COVID-19 era. And the second one, Professor, small autonomous robot is also sweet for small scale farmer. Since we have this culture, our farmers have small land and between the land, there is no road. So what is your recommendation then for our country? And then the third question is from Ms. Yovita, the same institution with Mr. Maisti. Does it is also applicable to be executed by small scale farming, considering the diversity between location or farming? What the crucial aspect should be underlined when we want to implement in different areas, particularly for small scale farmers? So I think there is a correlation among these question because of the difference type between the farming in Indonesia and the farming in Germany. So, Professor, please answer to this question.
Yeah, thank you very much, Rita. As I already mentioned, we have in Germany also these very small scale farmers, and they also have their land which is distributed in different areas. So we are talking about a few kilometers which they are away from each other. And in the concepts we have so far entering the market or being under development in science, there are mainly two concepts how to move those robots. One is to put it on a trailer and drive it to the field, and depending on the sizes is one way how to handle it. Another idea is that those autonomous robots be allowed in future also to drive autonomous to the fields by themselves. But this is something where we have to still have to define the legal requirements for autonomous driving, and most of them are able to drive on off-highway or all-terrain fences, so that one can put the robot from one field to another by driving it by hand, by example. You can have a controlled steering of those robots, for example, and you can drive them by hand from one field to another. I have to admit that I don't know the situation in your country, how the terrain looks like if there are no roads, but this is a good question we have to manage on. How does the system can look like where those robots are used in the whole process? Also the question, how many people do I need to operate these robots? How is the distribution concept, and all the questions I have addressed towards reliability, safety requirements, and so on. And this is still in work.
Okay, Professor, thank you. And we will see the next question. I think we still have time. From Mr. Agustomi Sitorus, the Nation Institute of Science LIPI. Dear Professor, I'm interested in your presentation related to problems in agriculture, namely the contamination of drinking water with dangerous chemical resulting from fertilization. My question is, how badly has this contamination gone on farms, and can you share how we can measure in the field so that we can reduce the level of danger?
Yeah, thank you. Also in Germany, we have some locations where we have higher problems with the contamination of drinking water. Those are those regions where we have the production of cattle and pork. They are concentrated in the northern part of Germany in a small region. And there we see that farmers put lots of nutrients on the fields from the animal production system. And this is something we have to solve for the future. And at the moment we are trying to drive the nutrients all over the country, sharing them on farms with no animals, but this is not very efficient. And our idea is that we would like to, how do you say, optimize the manure by processing it, taking out the water. So we have a lot smaller fraction, and then putting it on the field in the best way directly beneath the plants, so that the plants can have direct access to the nutrients. And there's a lot of research done in the last years that, for example, in corn, if you put the fertilizer beneath the plant directly, you can reduce the amount of nutrients needed by 50% without decreasing the yield. So we have to get better on the deposition of the fertilizers. Today we spread them on the field, and lots of them are not going into the plants. They are going groundwater bodies, or they are going away by after rainfalls. And this is something we have to optimize. And I think this could be an option, doing that with robot systems.
Thank you very much, Professor, for your answering. And really, we have some more questions. But due to our limited times, I promise to send you the question, so then maybe we can give the answer, the feedback to the presenter who show the feeling of interesting to your presentation. And hopefully this one is what we expect to be the outcome of our conference. And ladies and gentlemen, in the morning, we listened to the idea about smart farming, and now we listen from our professor about spot farming. I think these two knowledge for us today is very related each other in order to face the revolution industry 4.0, especially for the development of agriculture. And Professor, it is an honor for us to have a scientific discussion with you. And what can I say? It is a very expensive discussion, actually, expensive time for us. And we hope that this result will benefit for the future experiment and give positive contribution to the country. And it is very important to be strong or more powerful by having knowledge. And I remember one wonderful German quote, "Nur die Harten kommen in den Garten." So only the strongest will we survive. And now we are in a very hard condition, pandemic COVID-19. And Professor, vielen Dank for your presentation, for your knowledge. And I would like to invite the MC again, because they will guide the process of handover something for you. So please stay with us for the next 5 minutes.
Okay, thank you very
Please,
much.
Mr. Juzaili Ridwan and Miss Anna Misko. Again, maybe we have some things. Professor, you see that the participant is almost 200. So we have 50% of them all presenters.
Yeah.
And the rest is my students.
Okay.
I want to ask something, Professor. Is it okay?
Yeah.
Miss Rita,
Okay,
okay?
please.
I want. Okay. It's very happy to know that we will have autonomous robots with a lot of advantage. But I didn't get information from your explanation that the robot we can use it in land area because in Indonesia, like in Kalimantan, we have peatland area. Peatland, you know, peatland. If we planted rice in peatland, it
Yeah.
will be a problem. So many problems there because the peatland, when we go to the peatland, it will shrunken us.
Yeah.
So peatland, is it the robot we can use to the peatland area also for planting rice?
First of all, let me say the following. The robots I have shown are only theoretical concepts. They have just been designed in the computer and they are not really, they have not really been built. But on the market now, we have some concepts built by companies and they look like those robots we have developed. And they are constructed for German conditions. We don't have peat soils in Germany, so there's no need to have a design being able to operate on peat soils. But if there's a market for time of farming, then I'm convinced that some company will focus on that and they will find solutions for that. I've read a paper about, I think it was from Japan, where they had a robot, a swimming robot for rice fields, and but I don't remember what the purpose of operating was. But it was focused on the operation in rice fields, and very important product worldwide. And there will be solutions also in this area, I think. It's a matter.
Yes, but it's possible. It's very, very possible.
I think so.
Yes, I think. Because in Indonesia, is the wetland only in Kalimantan, and Kalimantan is consists of peatland.
Yeah.
Yes. In another place of Indonesia is only a little land for the farmer.
Yeah.
So it's better to use in Kalimantan.
In my eyes, autonomous robots have the great chance to substitute manual operating systems, all the things the workers do by their hands. This can be probably subsidized by small autonomous robots. And this is what I tried to say using this example of the combine harvester. Like 100 years ago, when we did not have a combine harvester, the people had to chop the grains by hand, they had to collect them, they had to flail them by hand, and they did it one step after another. And in a combined harvester, we combined all those processes in one machine. And this is why this machine is so huge. But we have the chance to also do that with small robots if we focus again on every single step. And then we will be able to do it also with small machinery. And in my eyes, all these hand-operated working processes could be also substituted by robots. although there are very different circumstances, if you work on peat soil or on other arable land, the design is just to fit to the circumstances. And why not having a swimming robot, for example?
Yes, very nice. It's very nice because consider our land is our land unit is very ergonomic, not the same on one another. So
Yeah.
autonomous robot is very functional. It will be built in 2015. The autonomous robot.
Pardon?
Commercial product when is commercial product of autonomous robot.
Our robot systems I have shown, as I said, are only a theoretical approach, only designed by computers. And but on the big technical shows, like I don't know if you know the ICATES, it's the world's biggest how do you call it, fair for agricultural technique, and it's in Germany. And in 2013, I saw the first robot concept shown by a company. In 2015, it's every 2 years, the Agritechnica, there were a handful of robot concepts shown by different companies. And on last year's Agritechnica 2019, there were first robots you could actually buy as a farmer. And so the development is very quick. And interested what will be shown next year on Agritechnica. And I guess that the number of robots will be a lot higher. But in my eyes, the problem at the moment is that those companies focus only on one operation. And what we need is a standard roboter. Like we have the standard tractor where you can attach any kind of working principle or tool to the tractor. And this is the same we need for the robots. We need a standard robot where you can attach different tools for different working processes, so that the investment into the robot is decreasing.
Thank you, Professor. Thank you, Ibu. Because of the time now, we will give the microphone to our MC, please, Mr. Juzaili.
Thank you very much too.
So online photo machen take more minutes, Professor.
Okay.
Because we cannot see all of us in one screen, so they
Yeah.
should move between the screen to get the picture of 200 people together.
It's quite a challenge, huh?
And will you stay or you will leave us? We will continue to the second speakers, Dr. Amro Babikar Hassan.
I will leave you because I have another appointment
Okay.
right afterwards. I'm sorry for that, but
However, thank you very much. And I will send you the rest of questions so that I can send
yeah.
the feedback to the people who has a big question in their
Yeah.
heads. And maybe I will send you some photo about our next one. Yeah? Okay.
Thank you very much.
You are welcome, Professor. Auf Wiedersehen.
Cheers.
Cheers.
So you already took the
Ladies and
picture of
gentlemen.
me? You already took the picture of me, so I can leave, or?
How is Mr. Juzairi ready or not? We are ready? We are ready, Prof. We will send you the photo and also the record maybe. We present this also live to YouTube, so many
Yeah.
people maybe can see our conference. Yes,
Okay.
we make it
So
live.
once
Okay.
again, thank you very much. It's been a big honor
You are
for me
welcome, Prof.
to participate on your conference. See you,
You are
Rita.
welcome.
Bye.
See you too. Bye-bye, and ladies and gentlemen,
Bye.
I know you are tired now, but we should continue our conference with our second invited speaker, Dr. Amro Berhasan. And first, I would like to introduce you about our speaker, Dr. Amro Babikar Hassan. And it is very impressive for us that he come from Saudi Arabia, but he is Sudanese. He currently working for Department of Food Science and Nutrition, College of Food and Agricultural Sciences, King Saud University in Riyadh, Saudi Arabia. He was the head of Department of Environmental Pollution Research and Studies, Environment and Natural Resource and Desertification Research Institute, called ENDRI, National Center for Research in Khartoum, Sudan, between 2015 to 2017. And he worked as part-time lecturer in Juba University and Al-Azhari University, Sudan, and all-time as researcher at ENRI. The focus of his research is food safety by using the application of non-chemical treatment to eliminate contaminants such as store pests, as well as to improve the functional properties, nutritional stability, and quality of the agricultural products. And as additional information, he is German alumni, and between 2017 to 2018, he took a postdoc fellow research in food safety at Bern University, Switzerland. So he has a lot of experience to share with us. And now we will invite him to present with the title Electromagnetic Energy in Food Technology, Principle and Application. So Dr. Hassan, the microphone is yours, please.
Thank you, Rita, Dr. Rita. And did you hear me? Do you hear me now? Is it okay?
Yes. Yeah.
It is clear. Okay, thank you so much. And thank you. Before we start, I would like to thank the coordinator of this conference to invite me one of the key speakers. And yes, and I think I do have to share my screen first. Okay. Okay. Previously, we heard to Mr. Wegner or Professor Wegner that about working in robot in the pre-harvest technology of agriculture. But now we will turn to the other part of technology, but in the field of post-harvest technology. And in this part, I would like to give you some principles of the electromagnetic application of the electromagnetic energy in the food technology. And also I would like to show some application. I mean by application, not industrial application, but I will show you some results of our research application. Firstly, I have to give you some information about the electromagnetic energy. You know, this electromagnetic energy, as you know, came from electromagnetic spectrum. And as you see in the right side in the picture, this electromagnetic spectrum consists of a lot of fields, energy fields. And each of energy field has own wavelengths and frequency. And as you see here from the spectrum, that is the most important things, this spectrum divide into two categories: ionizing radiation and non-ionizing radiation. What we mean by ionizing radiation, that is energy able to ionize water molecule in food, and non-ionizing radiation, we mean it's not able to ionize the water molecule in our food. And these energies, or this electromagnetic energy, can be divided into gamma rays, X-rays, and this considered as non-ionizing radiation, sorry. And then we turn to ultraviolet light. And so in this area, we can see the visible light, and as you know, this consists of lights. And in the left side, we have this non-ionizing radiation area or field, which consists of microwave, infrared energy, microwave energy, radio frequency energy. And what is the difference between the important difference between the energy in the field of energy in the spectrum, that they are different in the frequencies, and also in the wavelengths. So if we see this part of this field of the non-ionizing radiation, and also we have X-rays and gamma rays, this is a part of ionizing radiation. Non-ionizing radiation have the lowest frequency compared to the very high frequency of the gamma rays or X-rays. That's why they can make ionizing radiation for water molecule in food. And also these fields has longest wavelengths, like in the radio frequency and the microwave. Sometimes it reach meters or more than 100 meters in the case of radio frequency, but they produce lowest energy compared to the gamma rays and X-rays. And so now we come to the question why we want to use this electromagnetic energy in food application. And as you know, in the post-harvest, we have a lot of losses of food now in many countries or developing countries particularly. It reached up to 30%. And the annual loss, it reached up to 30% due to the infection of the crops or food during harvesting, during the processing, also during the storage. So generally, chemicals are widely used to control this pest and also to reduce the loss. And as you know, wide application of these chemicals have a negatively effect on the environment and also affect negatively to human and animal health. Therefore, the industry have been explored to apply alternative safe methods. And one of these methods now, in the last decade, they would like to apply electromagnetic energies in different fields as one of the alternative methods to the chemicals. So we use electromagnetic energies in food for controlling pests. We would like to, in controlling pests, we mean by pests here, insects, also fungicides, and particularly these infect the food during storage or after harvesting. So, by application of these energies, we can expect to extend the shelf life of food and also enhance property of food. We mean by properties, nutritional properties, and also industrial properties. And hence, application of this energy also increase the availability of some nutrients like mineral and antioxidants. And you know, most of plant sources are usually considered a source of mineral and antioxidant, but this mineral and antioxidant combined in our food, or for example in grains, they found combined with other components that make it not available for digestion system. So by using this application of energy, it may be do some increasing of the availability of the mineral antioxidant inside food. So application of this energy in food is not easy. We need some optimization of different factors. For example, it depends, this factor depends on what technology we use. For example, if you use gamma radiation, we need to optimize the doses with the time application. And also if you use microwave, because it's a one of generation of heat, we have to optimize the factor of temperature and time. Why? Because we have to make a balance. Maybe, as we said, the application of this energy cause control of pest, but if we use it for extensive time and high temperature, for example, we can decrease the quality of food. So by application of this energy, we have to make balance between controlling the pest to extend the shelf life, and on the other hand, we have to maintain or improve the food quality. So application of this energy had many advantages, and the advantage belong to different concepts. We have environment concepts, time concepts, and resistances concepts. What we mean by an environment concept, as I mentioned before, that the application of chemical fumigants or chemical pesticides or insecticide result in the residue of these chemicals in food. And this will cause very hazard to the human health or animals' health also. So application of this energy, we found that they have no chemical residue left on food. And also there is no environmental hazard for application of these technologies. Now everyone at home has this instrument for heating food. So why it can be used for other purpose in food industry, like controlling insects and controlling pests. So application also of this energy are safe and eco-friendly system, eco-friendly methods to the environment. Regarding the concept of time, application of this technology had a very short application time. For example, for heating by microwave, we don't need like to heating in conventional oven dryers or oven at home. If you want to heat your food, you use microwave only for short application time, but for oven you need longest time than microwave. By using short application time, we minimize the food damage definitely. I mean by resistance here, this only concept for the insects and like fungi. Using the same chemical, pesticide or insecticide will make the insects or the pest able to develop resistance system against this pesticide. But by using this technology, we can there is no chance to the insects or the fungi or bacteria or the other microorganisms to develop resistance system in their bodies to resist it, because simply maybe they will die directly after treatment. So in this presentation, I will give you some applications of this ionizing, this electromagnetic energy in the term of ionizing radiation, or I mean particularly application of gamma radiation, and application of this ionizing radiation have many advantage in the food industry or food technology, for particularly for controlling store pest. So ionizing radiation or application of gamma radiation can be used for controlling insects because they use to kill the insect directly, not directly after treatment, but they damage their DNA, so they cannot make any, they don't have any another or advanced cells activity. And there are many type of ionizing radiation applicable in food, like gamma radiation resource, and this from cobalt 60 or cesium 137, also high energy electron and X-rays. But the most common use in the food industry is from the resource or radioactive resources of cobalt 60. So it used mainly for control food after harvesting or post-harvest technology as a post-harvest technology. Why? Because they are able to penetrate inside the grains, for example. So if any infection of insects inside the grain, these only by gamma radiation or these ionizing radiation are able to kill the insects inside the grains. And you see here from this picture, it's clear that the development of these insects happen inside the grains. So if you see grains after harvesting, it will be it's okay. After 2 days, after 1 month, 2 months, according to the condition we found, we saw many insects in our products. From where they came, even you store them in a very good condition, in the isolated area, they came from the field because they are infested with a egg, and they develop to larva, pupa, and then produce adults. So by treat these grains with a gamma, because gamma has an ability to penetrate inside, is able to kill all these live stage of insects. And this can be one of advantage of application of these electromagnetic energies. So application of this energy, when we apply this, we have to measure the first time the dose, and the dose we know measuring the irradiation dose is known as the dosimetry. So the dose is measured by kilogray, and 1 kilogray equal 1,000 grays. So according to these doses, application of food industry or food technology have been divided into 3 categories. The first one is a low dose application. It's up to 1 kilogray. And this used for many purposes, for controlling insects. We don't need for controlling insects more than 1 kilogray of maturation. So in this technology, in the inhibition of maturation, we mean that we can stop any enzyme work after harvesting, for example, to keep the physiological of the physiology of plant longer, and also inhibition is sprouting. And you know that in the humid area, like the tropical area, if you harvest grain and store them in the very humid area, so they are able to germinate. So by application of low doses of gamma radiation, so we can inhibit this sprouting. The second one is a medium dose application. It's from 1 kilogray to 10 kilogray, and this mainly to extend the shelf life of food. I mean by food here, I mean grains, legumes, and also spices. So we can extend the shelf life. we cannot, it can it can increase the resistance to if as I mentioned before, if we treat the grains before storing, so we can uh, kill all the developing stage inside the grain, so we can extend the shelf. No other adults will develop, so it will increase the shelf life of grains, and also reduce the microorganism level of food or crops. Thirdly, we have high dose application. It's above 10 kilogram, and this mainly to sterilize some canned foods. And also we can sometimes some spices we need to application more than 10 kilogram, but not more than 20 kilogram. Secondly, I will show you the dielectric heating or dielectric heat treatments in food. We mean by dielectric heat treatment these two field of spectrum: radio frequency and microwave. Cause of radio frequency and microwave known as non-ionizing radiation. So they are not able to ionize the water molecule in food. Although they have these characters, the same character, but they are different mainly in the frequencies. So we found microwave it has a higher frequencies than radio frequency. On the other hand, the wavelengths of microwave is shorter than wavelengths in radio frequency. Although microwave and radio frequency have different bands of frequencies, only few frequencies are allowed to use in industrial, scientific, and medical purposes or application. In the radio frequency, we have only these 13.56 megahertz, 27.12, and 40.68 megahertz allowed to apply in food industry. And also in the microwave, we have only two frequencies are allowed to use: 915, which is not common, but the next one, 2450 megahertz. This is common, and if you check your microwave at home or check your mobile, you will find the frequency. This written at 2450 megahertz. Also, microwave radio frequency are differ from for a very important things, that is the wavelengths, the wave of the microwave and the wave of the radio frequency are different in their regularity. So in radio frequency, we have a very regular waves they come from the sources of the wave. So in the radio frequency, we found very uniform heat distribution in our product. However, in the microwave, we have this irregular shape of the waves inside the cavity of the microwave. That's why we need to rotate the product during the microwave treatment. And now you can see that at your domestic microwave, it has to be rotated for at least 6 RPM. So we have these two infrared photos. This for grains that without rotation, we can see very range from 19.5. This is the lowest one, so we can ignore it. But we have these points, cold points in our products, and also very high temperature in some products in points up to 115. But after rotation, it looked to be very nice. Not, we cannot be sure that all the grains have the uniform temperature, but from the overview, it will be mostly uniform. And how the microwave and radio frequency work to heat the grains or to heat the food inside. So you know that this frequency, if we have this dipole molecule, and most dipole molecule in food is a water molecule because it consists plus or minus uh, charge. And you know that this is a microwave. When the wave of the microwave or radio frequency came, they are electromagnetic waves, so they have plus or minus, but they are rotated, they are frequented. So, and you can see, for example, in the microwave we have 2450 megahertz. What does this mean? That means this hertz can be rotated 240 for 2450 rotation per second, multiplied by a million per second. So we can imagine that if we have a water molecules inside, it rotates like this, 2450 multiplied by a million times per second. And we don't only have this one molecule of water, we have billion molecules of water inside our food. So this one, billion million times and billion molecule of water doing the same action at the same time. So we can expect that the high frictions between the molecules and also the rotation of the molecule itself generate heat on all the products. That's why for the radio frequency and microwave, we have this volumetric heating, and for the so that we can find the uniform and rapid heat in our products. And this converts, if you compare to the conventional heating, we have this conventional the heat come from by radiation to the conduct, and they have the found that in the surface the temperature is different from the middle of our food. Also, we have this ultraviolet or UV light. And if you want to define UV light, is electromagnetic radiation with a wavelength shorter than visible light, but longer than X-rays. And they show it's after from the spectrum, we found that it come before the visible light, but after the ionizing radiation here, X-rays and gamma rays. So it has a longest wavelengths, but show lowest frequencies than X-ray and gamma rays. So application of UV light categorized into several categories regarding to the wavelengths. We have UVA with a wavelength 315 to 400 nanometer, and this use only this can harm human skins, and also used for processing of tannin. We have also UVB with a wavelength 180 to 350 nanometer, and this sometimes it can be used for food, but we have to be careful because it causes skin burning for the human. This and sometimes lead to skin cancer. And we have the last one, UVC, with a shorter wavelengths, 280 to 100 to 280 nanometer. So it can be used to inactivate bacteria and microorganisms in food. So application of UV light in food and recommended only with UVC, and it can be defined as disinfect method with a shorter wavelengths and with response to kill or inactivate microorganisms. They have destroyed the DNA of the microorganism, and also even they are alive, but they are unable to perform any cellular function. So we can use it UVC in food, air, and also water purification. And the important things to measure to apply UV, we can measure the UV doses by using this instrument, or we can calculate the dose by UV intensity, which you can, for example, if you have UV lamp, every properties. We come with these UV lamps. It will be written the UV, what about the UV intensity, and also if we multiply by exposure the time, for example, in seconds or minutes, so we can get the UV dose which you use for food industry. An application of this electromagnetics energies, as I told you before in the beginning of the presentation, I will show you some application which we did in the last times. We apply these energies for cereals, for different part of cereal, for corn, millet, and sorghum, oil seeds, sesame, and peanut, and also for legumes, peanut, white bean and fava bean, and also spices. And as Dr. Rita introduced me that I came from Sudan, from the tropical, and use all the for the tropical part, but also use with the spices. So we check this. We use this for application for food to increase the storability. This gamma, microwave, radio frequency, and UV to increase the storability in terms of increasing the controlling the pest, enhance the germination quality of food, and also inhibition of some enzymes. Also, we use it for nutritional value, to increase the nutritional value like protein content, increasing the antioxidant in food, and also for the functionality and availability of some minerals and protein. In this time, I will show you application of this energy in spices. So firstly, I will show about application on gamma radiation in spices. We use it against dried hot pepper, fennel, and cinnamon. And our objective mainly to decrease the microbial load of these fungi, these spices, and also to enhance the phenolic, flavonoid, and antioxidant capacity of these spices. And we depend on two hypotheses that gamma radiation can damage the DNA molecules of the microorganism, and also they are able to break some chemical bonds of the polyphenols, so it become more soluble and increase the content of phenolic compound of the spices and increase the antioxidant capacity of the spices. So we apply spices in this radiation unit with the cobalt 60 sources, and at that time the dose rate of this device is to 25 gray per minute. And so we apply different doses of gamma radiation, 2.5 kilogray and 215 kilogray to these three type of spices. And we found that this gamma radiation can control the bacteria and fungi growth in all spices we use. So we need up to, I will use it, as you tell you, use up to 15 kilogray, but we found that by increasing the gamma dose, the mortality of the fungal growth or the bacteria will increase, sorry, and also increasing the dose increase the phenolic and antioxidant compound. But if we use the dose up to 7.5 kilogray, so some of these phenolic like flavonoids in the spices start to decrease. But we found that we have very high variability between the applications, technology, and the parameter we measure in the spices. Secondly, we use also microwave for decontaminated spices, the same spices, hot pepper, fennel, and cinnamon. So with the same objective to decrease the microbial load and also to enhance antioxidant capacity of these spices. and we depend that microwave will generate, beside its energy produced by waves, also it generate heat, so it can cause death for the microorganism, and also heating of food or spices maybe do some change in the matrix structure of the phenolics and antioxidant compound, so it will increase its solubility and become more soluble and more releasable for human. And as you know, that's the important things for application of this technology. We have to combine or to make balance between controlling the pest and also to maintain or enhance the nutritive value of food. Therefore, it is very important to control the temperature during the microwave or treatment. So we treat the samples with a microwave power 500 watt and only two application time 45 and 90 seconds. So why we use this 500 watt? Maybe we can use 300 watt, but we need longest application time. If we use higher power, for example, more than 500 watt, we need it will increase it rapidly increase the temperature of the products. That's why we concentrate only on 500 watt with only this short application time. And the temperature of the spices measured directly after treatment by using infrared thermometer in different points, and we get these points. For example, if we see here at 45 seconds, we have a temperature of the product around 50. This is surface temperature, and we've applied more than 45 seconds. For example, 9 seconds, the time temperature would rise to 60 and 70 degrees centigrade. And what we found that application of the microwave energy or microwave heating for 45 and 90 seconds, very efficient to control the bacteria and fungi growth in the products. And also we found that the shorter application time, 45 seconds, increase the total phenolic, total flavonoid, and also antioxidant capacity. However, at 90 degree and at 90 seconds application of microwave at 90 seconds or more than 45 seconds, it's the content of the phenolic compound and flavonoid start to decrease. But at 45 degrees, so it will be okay. We can, so maybe we can use it as optimum condition, 45 seconds at 500 watt for to application and these spices with a microwave heating. But we have to be very efficient or to choose, because if you use, for example, other spices, we need different conditions. Finally, we apply UVC radiation in spices, also to decrease the microbial load in spices. Not only the total count of bacteria and total count of fungi growth, but also we check the Salmonella species and E. coli. And also our main objective is to enhance the antioxidant capacity of three spices. The same we depend on that UVC causes damage of the DNA of microorganisms, which is good, so we can control them. And also UVC cause an activation of some enzymes which responds of synthesis of this phenolic compound in plants, so that can increase their antioxidant capacity. We apply this UVC in the metal box with these dimensions, and also we keep the product 15 centimeters from the UV sources, and we apply the UV for 20, 40, and 60 minutes, and the calculated doses was found was been 3.5, 7, and 10 0.4 kilojoule per meter per square meter. What we found that we found application of UVC can control bacterial fungal growth and also eliminate the salmonella and E. coli from all type of spices we use, and also increase significantly the content of the phenolic and flavonoid and also antioxidant activity of the spices. And also the important things that we find that by increasing the dose, we increase the amount of phenolic and also increase the amount of antioxidant activity. So from these results, we can conclude that the gamma radiation dose less than 10 kilogray, it could be possible to reduce the microbial load, the bacterial load, and also fungi load in the spices without any major effect of antioxidant of some of the studied spices. Regarding to the microwave is a power 500 watt with a shorter application time, reduce the microbial load and also maintain the antioxidant capacity. Similarly, by application of UVC, treatment could be useful to enhance the nutrition value and also can prevent microbial growth in spices. So we can conclude that this treatment can play a positive role in the effective preserve the alternative method in food industry. And we are now continuing to do some another not application of this, but we use it after we have to check the shelf life of spices, and this is of spices after treatment with these electromagnetic energies, but it are still under studying. We don't get the result yet. And also I would like to thank you for
You are welcome, Dr. Hassan. Thank you very much for your bright idea in your presentation. Yeah, it is the result of your long time research work. So we just can learn about it in 1 hour. And thank you for your 35-minute presentation. Actually, we want to listen, but the time is very limited. Okay. And you know that we have also some questions for you. But what is your opinion? Is it okay if I send the question and then you give the feedback by writing, and then I can give the feedback to the participants?
okay.
You see, where is it? Actually, I want to show you, I mean, the questions. I'm sorry, I lost my presentation. I don't know. Maybe I will read for you some question. For example, you said that this technology is safe and eco-friendly. Is there any effect to the human body? Like it is dangerous for our DNA? And how expensive this technology? How we can calculate the benefit of using this? So it is okay to put high investigation at the beginning, for example. And what is your recommendation, doctor, to use microwave or radio frequency? And can we apply this technology in continuous process? By meaning of useful for industry. I will send you the question. Then I want to say thank you very much for this presentation far away from Saudi Arabia. And all of us love to go there to Saudi Arabia. And now I want to give the microphone to our MC. So please be patient for some more minutes, Dr. Hassan. Please, Mr. Juzaili Ridwan and Miss Anna Misko.
Okay. you so much. Thank you too much.
If you have the plug behind you, may you show us, Dr. Amro?
What?
Do you have the placard behind you?
Yeah, not clear or what?
Maybe you can show us the placard that you received.
Okay.
Okay. So the participant can see that it
Thank you
already
so much.
arrived. Yes. Thank you very much.
Thank you. Thank you.
Terus mainnya ada yang masuk. Udah
Excuse me.
Saya harusnya di ruang room 2 tapi di layarnya munculnya itu ya.
Excuse me, sir.
Yes.
I should be going to room 2, but I was inviting to room 7. Can you fix this?
To room 2.
Yeah, but I was inviting to room 7.
Okay, wait.
Halo, Assalamualaikum. Saya juga, Dek. Siapa nih hostnya?
Oh iya, Bu.
Saya kan Suyanti Kasimin, harusnya di room 1.
Oh iya, Bu.
Jam 15.30 tadi, ini belum masuk-masuk.
Oke, Bu, ini saya kirim ke Ibu Suyanti ya.
Ya, room 1, Dek ya.
Sudah.
Ini saya join, Dek ya.
Oke,
makasih.
Sama-sama. Maaf, Ibu Ifma Linda tadi?
Iya.
Dari room berapa?
Iya, saya harusnya di room 2, tapi ini di invite-nya ke room 7.
Oke, sebentar.
Ya, terima kasih.
Oke, sudah saya kirim ke room 2. Tinggal join saja, Bu.
Ibu Jupitriani itu udah ya?
Iya.
Ibu Jupitriani Ismi tadi udah ya?
Udah.
Room 6.
Room 6.
Saya alihkan ke room 2.
Untuk Bapak Ibu yang lain, ada yang ingin masuk ke room berapa? Mohon konfirmasinya. Untuk room 3 bagaimana Bapak Ibu? Apakah ada yang ingin join ke room lain?
Belum.
Rudi, kalau Ibu bisa disetting masuk ke room mana aja?
Bisa, Bu, bisa.
Coba dibuat gitu biar Ibu mau bisa jadi. Tapi mau sholat dulu ya.
Ya, boleh, Bu. Udah, yang di room 3 sudah saya berikan undangannya. Klik join. Yang partisipan sudah bisa untuk konfirmasi join untuk ke roomnya masing-masing ya. Ibu Yusma ini ada untuk mau masuk ke room berapa, Ibu?
Bagus ke sana apa bagus fakultas? Fakultas aja boleh juga. Pasang lagi.
Untuk Ibu Jovitriani Ismi masuk ke room 6 Bu ya?
Ya. Udah masuk kan?
Udah saya undang tadi.
Belum masuk ini Pak. Saya belum bisa
Oh iya
masuk.
nih, coba saya undang kembali. Ada layar zoomnya
Oh iya,
keluar Bu.
sudah,
Oke.
sudah.
Aku tanya di moderator di room 7 kan tidak ini kan
Bu Rita, Ibu.
Ya.
Ibu bisa masuk sebentar ke room 7 untuk sebagai moderator Bu. Pak Darwin belum bisa dihubungi nih.
Oh gitu ya? Karena ini mau sholat.
Enggak,
Oke.
untuk memulai karena kan udah pada nunggu Bu.
Oke.
Sebentar Bu.
Pak
Ibu.
Darwin ini kasih tahu nanti jangan salah paham.
Iya, dan Bu nanti konfirmasi ke Pak Darwin.
Udah.
Bentar Ibu, dari room berapa tadi ya? Bentar Bu ya.
Udah masuk.
Udah. Pak Darwin.
Muhammad Rita Khatir.
Oh, udah.
Mahasiswa tuh.
udah masuk.
Udah.
Darwin.
Bukan. Memang itu Bu Rita. Oke, sudah Pak Safrijal. Sudah saya kirim ke room 3. Untuk Bapak Ibu yang masih ada di dalam room ini, ada yang ingin masuk ke room berapa Ibu? Bapak?
directly in portable mode, something like that. Okay, so that will be very good. Then for the knowledge, yes, yes.
And this is very useful for,
Yeah. Okay. Okay.
Thank
So
you.
thank you for very nice presentations. Now
you.
time is up, and then we need to move to the next presenters. Now I will invite Mr. Delvian. Are you here? Mr. Delvian? No, yeah. Okay. The next is Miss Dian Hasni.
Yeah.
Okay. So now is the time for you to present your works about coffee. I guess this one. That's very interesting. So you have 8 minutes. And after this, you can directly share your content and then start your presentation. Now time is yours.
Okay, thank you very much for your time. And I will directly present our work, which entitled Comparison of Radical Scavenging Activity of Commercial Arabica and Robusta Coffee based on roasting method and brewing condition. So we all know that coffee is known as brew and pleasurable drink for joy and also stress releaser due to the caffeine which contain in it. Not only contain caffeine, coffee also contains active compounds such as chlorogenic acid, nicotinic acid, trigonelline, quinolinate, trilogalate, and also caffeine as I mentioned before. This active compound is responsible for its flavor and surprisingly also for health benefit. Many research has been found that many researchers have been found that coffee also considered as well as antioxidant drink, and this this firstly found by Almeida and then continually increase many investigation how the antioxidant activity is changing in different way in different way and in different process. And Sunarni reported that Robusta has higher antioxidant than Arabica, even as a drink or as a bean. Antioxidant activity in Robusta around 1 up to 7, where the extraction result as a drink 140.42 ppm. Unfortunately, all of the coffee processing, such as roasting, grinding, and brewing, may reduce the antioxidant content in coffee, since this kind of process need heat treatment to do so. So, this research aims to analyze and compare the radical scavenging activity in 3 parameters: total phenol, antioxidant activity by DPPH, and also IC50 of commercial coffee based on its coffee varieties, roasting technique, and shelving condition. So the main ingredient we use commercial Arabica and Robusta coffee. Why? Because this is we like to know how the antioxidant activity in a commercial coffee before we do it in our laboratory. So commercial coffee was boiled and then roasted, packed in aluminum foil at room temperature, and then stored at room temperature at 1 day prior to analysis. So we boiled 1 day prior the fresh commercial coffee. the coffee based on its variety, Arabica and Robusta, and the roasting also standard and torrefacto. Standard roasting is the common roasting method, and torrefacto is the one kind of roasting where producer or roaster put 10% of sugar in the end of roasting process. This kind of method is common use in traditional coffee shop in Aceh, and also common use in Italian coffee shop. And also the serving condition, manual brew, and also boil one. Many traditional coffee shop in Banda Aceh use kind of to boil the water together with the coffee ground in to serve the coffee. So we have 24 experiment unit and ANOVA and least significant difference as continuous statistic results. This is the process. So the coffee need to be roasting first, and then we serving it based on different condition. The results show that roasting, different kind of roasting, yeah, torrefacto has a higher. The results show that roasting and serving method had a very significant effect on total phenolic content. Roasting condition and the interaction among treatment have significantly affect the total content of phenol in the coffee drinks. So the total phenol of Robusta seems to be higher than Arabica coffee. But roasting and serving brewing coffee can reduce the coffee or boiling coffee can reduce the coffee or polyphenol content. If we serve coffee with a manual brew, it produces higher total phenol rather than the boiled one. Yeah. This is because the higher the temperature and the higher the pressure applied by brewing method, the greater the number of water-soluble components such as chlorogenic acid, caffeine, and nicotinic acid can be extracted. That's why the polyphenol content, total phenol is also higher. And also the antioxidant activity. Antioxidant activity here is influenced by presentation method and also coffee varieties. It can be seen as well, Robusta has the higher content than Arabica, and if we serve coffee with the brew one, it also has the higher content rather than the cooked one. The influence between interaction between serving method and roasting method also has influence in antioxidant activity, whilst brew has the higher antioxidant activity than the cooked one. For IC50, it can be seen that conventional Arabica with a brew method has the higher IC50 rather than the others. So from all the data parameter, we can conclude that Robusta, which has been roasted with the torrefacto method, yeah, has a higher scavenging radical activity rather than the other varieties. And also, based on total phenol and antioxidant activity analysis, the best treatment was obtained from torrefacto Robusta coffee drink with brew serving method. Further research is needed to determine the effect of the degree of roasting and antioxidant activity, and also to determine the amount of chlorogenic acid and other components of the phenol chemical component that act as antioxidant in Arabica and Robusta coffee drink in Aceh. Thank you very much for your attention. I will stop my presentation here and come back to the moderator.
Okay, thank you. You spent 9 minutes, so
Oh,
only
I'm so
1
sorry.
minute left. Yeah, no, that's okay. That's okay. Uh, okay, so I will invite the participants to ask one or two. Just one question for you. Okay. Anybody?
I think there are one question from Koifani Azahra.
Yeah.
Room.
Okay.
I have some. Is it dangerous to consume too much caffeine in coffee?
Okay.
So yeah, as an Indonesian idiom ya, jangan mengkonsumsi. Don't eat too much. It will be affect your health. But you caffeine is astringent, or we can say that is bahan penyegar. How we say it? I'm forgot. Nah, so caffeine, when you use it in a suitable amount, it's good for your health. Yeah, but when you consume it too much, yes, many research have been reported that it will affect your health activity, especially when you combine it with smoking. So we can go back to the idiom, don't eat. Kalau kita makan terlampau banyak, itu akan berlebihan. Tapi kalau kita minum atau mengkonsumsi secukupnya, it will be okay. I think that's a good idiom.
Okay, thank you for the questions. I think now time is up. It's 11 minutes, and yeah, please give applause to the presenters. That's very nice presentation. Now we move to the next presenters. I will check first, and okay, now I will invite Miss Ade Cherry with Mr. M. Maki.
Yes, I will present on behalf of Dr. Cherry.
Okay. So you will present works entitled "Non-Destructive Evaluation of Oil Palm Fresh Fruit Bunch Quality Using Thermal Vision." Okay, you have 10 minutes, 8 for presentation and around 2 minutes for the Q&A. So after this, you can share your PPT directly. And now time is yours.
Okay. Just a moment, please.
Okay.
Hidup nih laptopnya nih. Oh, iya enggak, ya kayak tadi masih dicabut aja. Si orang.
Hello.
Yes.
Can I share my presentation?
Yes, sure.
Okay, thank you very much, Mr. Chair. So, due to certain condition, I will present the results of the thermal vision of oil palm with fruitlet under different temperature on behalf of the lead researchers, Dr. Cherry. So,
I'm sorry, sir. Can you please turn on your video, please? Your video, is it possible?
Okay, just a moment, please. Right. Okay, yes.
Okay, yeah.
Sorry to that. Thank you very much, Pak Arifin. And then In this presentation, we would like to explore the possibility to store the fresh oil palm fruits to extend the shelf life and process the fruits in the later days, because we know that the time constraint for processing the fresh fruit bunch of oil palm is the main driving factor to produce excellent quality of the oil palm. So the background of this study is the proper handling of fresh fruit bunches of oil palm will prevent the damage. And when we extend the processing time or increase the delay of the processing of the fruits, it will increase the free fatty acid inside the oil when we extract it from the mesocrabs. So what is the free fatty acid? Free fatty acid is the undesirable content or chemical components that we would like to remove when we obtain the oil from the oil palms. And therefore, with reduction of the free fatty acid, we will increase the quality of the oil itself. So the oil quality have the strong correlation to the ripeness of the fruits when harvested. Therefore, we need to harvest the fruits at the certain ripeness level, and then immediately we process the fruits to extract the oil. So we will prevent the degradation of the oil, and we will obtain the best possible quality of the oil from the raw materials. Okay, so reduction of fruit temperature immediately after harvest can be extended in shelf life, and this method already implement to several fruits such as dates, and then we have tropical fruit as well as strawberry and other fresh fruits. And we also understand that free storage has the advantage of maintaining the quality of agricultural products. And sometimes when we freeze the product immediately after harvest, we can extend the shelf life of the product in fresh condition up to 6 months. And therefore, in this research, we try to simulate the condition of immediate freeze storage of the oil palm fresh fruit bunch. And we hope that after we store the fruits in certain temperature, we can maintain the freshness of the fruits, and therefore, when we extract the oil from the fruits mesocrabs, we will obtain the similar quality of oil as compared to when we obtain the oil from fresh fruit directly after harvest. So in this study, we observe different ripeness level of the fresh fruit bunch, and then we store the fruit at -20 centigrades for different days. And then before we evaluate the fruits, we acclimatize the fruits from the cold storage into room temperature, and we use a thermal camera to monitor the change of fruit temperatures continuously. And based on these thermal properties of the products, when the temperature increased from the frozen -20 and acclimatized to the room temperature, we can distinguish the different criteria of the thermal properties, and then we can correlate the thermal properties with the fruit quality as well as the oil quality afterwards. Okay. So in these results, we understand that the oil content in the fruits changes during ripening, and the process are in parallel with the metabolism process that happen inside the fruit itself. The metabolism include the catalyzing of physiological change, biochemical change, as well as respirational change. And the process continuously occur on the onset of flowering up to the point where the fruit is harvested. And then we also observe that water thermal capacity is higher than oil, and therefore we can differentiate the ripeness of the fruits based on the ratio of oil and the moisture content in the oil measure crops. And the third result is that when we open the storage and we put the fruits out to the climatization process to the room temperature, we saw the difference of thermal change properties between ripe and unripe, and between fresh and unfresh, as well as between fruits that have good quality inside it mesocrop with other fruits that have slightly degrade or has excessively degraded oil quality. So in this graph, we saw that during the observation times and the increase of temperature from the storage temperature up to the room temperature and beyond to the processing temperature, which is we set at 50 to 60 degrees, we saw that the fruits that have more moisture contents will have slight delay for reaching from freezing temperature up to room temperature. On the other hand, the fruits that have most oil content will have better acceleration towards room temperature as compared to fruits with less oil content. And therefore, we can differentiate that when we observe the change and properties of the temperature change of the fruit mesocrop, and then we correlate it with the moisture and oil ratio of the fruits, then we can immediately understand that this type of fruits will have a higher oil concentration, and this type of fruits will have a higher moisture concentration. So we understand that to calibrate the process, we need to compare our measurement with a standardized device, and therefore we use the standard thermometer, and then we measure the surface of the fruits immediately when or in parallel with the thermal cameras. Okay, so we have the good coefficient of determination to observe the change in temperature as well as to observe the oil quality, the fruit qualities using the thermal camera. And from these results, we can conclude that. From this result, we can conclude that. Yeah. Yes. And then from this result, we can conclude that we cannot observe the fruits freshness and quality index only using visible or visual inspection only, but we need to use a thorough vision or thermal vision to when we acclimatize the fruit from the storage temperature onto the room temperature. And you can see in the picture that the appearance of the fruits thermal hugely different. You cannot distinguish between the fruit with certain temperature in visual inspection, but you can, or you are able to observe the change of temperature when we use visible inspection regime. I think that's all our results. And in conclusion, that evaluation of oil palm fruit quality can be extended in detail whenever we use the non-visual inspection, such as infrared or thermal radiation. And in this study, we conclude that thermal radiation produce better results in evaluating the quality of fruit itself as compared to visual inspection. So I think that's all the presentation. Thank you very much. And I would like to thank the Ministry of Research, Higher Education, and Technology for providing the fund, as well as the University of Andalas professorship in Andalas University 2020. Thank you very much. Okay, the chair, I return the time to you. I think you need to unmute your microphone, Pak Arif.
Okay. Yeah, just realized it. Okay, thank you. Okay, that's very nice presentation. Even though the time is up already, actually now 10 minutes, but if one of two from you will give question, I can spare around 3 minutes. Is there any question? Okay, if no, and then I have one short question for. Sorry, I'm talking with Pak
Maki.
Pak Maki. Okay, yeah, with Pak Maki. Okay, Pak Maki. I can see that the temperature of the fruits highly influence the measurement, right? Yeah. Now my question is, how about the temperature of the environment? Let's say if I measure at 30 degrees C, I mean the temperature of the air and also the relative humidity, will they influence also the results?
Okay, in this study we only make measurement in room temperatures.
Okay, but
in controlled environment, we do not provide or we do not conduct the measurement with different temperature regimes. We only use laboratorium temperature to set up the room.
Yes, I am.
Okay, yeah. So you will give the presentation again, the same as the previous one. So you have 10 minutes, around 7 presentations and 3 for the Q&A. You can share your PPT directly now, and afterward you can start your presentations. Time is yours.
Okay, thanks to the moderator.
Yeah.
Assalamualaikum warahmatullahi wabarakatuh. Okay, I will present my research about non-destructive evaluation quality of oil palm first fruit bunch based on optical properties using artificial neural network. I am Melidawati and my lecturer Dr. Dina Cherry, Kandra Fahmi, and Muhammad Maki. I'm from Agriculture and Engineering, Universitas Andalas. The background of my research is oil palm is one of the oil producing crops with the highest productivity level. Indonesia had a palm oil plantation area of more than 12 million hectares with palm oil production of more than 36 tons. The quality of palm first fruit bunch is affected by harvesting activities because when harvested at the right time, the FFB will produce good quality oil. To get good oil quality, we need a way to replace the harvest determination process based on visual observation. Because visual observation have the weakness is that it requires a very experienced operator, but still carries a significant risk of error. And another method of harvesting oil palm is using harvest rotation. We use harvest rotation. When the harvest is done too early, it will result in many fruit that cannot be harvested. Meanwhile, when the rotation is done too slowly, it results in high losses such as fruit passing ripe, rotten fruit, and the number of lost fruit which are not good. One way to consistently observe the quality of an object is by observing the physical properties or appearance of the product. Physical properties can be observed using optical device such as camera. One of the quality parameter that is influenced by the level of maturity is the oil content. If the level of maturity of palm FFB is high, the oil content of palm FFB will also be higher and will decrease with age or overripe. This is because when it is overripe, the cell walls will crack and also break so that the oil easily get out of the cell and the fat sac are torn. However, in the field, the determination of the maturity level of palm FFB is still done traditionally and proven by the quality of the oil in the laboratory. This causes crop error and requires expensive, long time, and extensive resource. So, my research about therefore this study will examine the correlation of the optical properties of FB with the maturity level of oil palm FFB and obtain a predictive model. Material and method from my research, the firstly yaitu di study. In this study, the selected oil palm plants are already production and are at least 7 years old because 7 years old productivity of oil palm. Uh, Next, the sample used in this study was FFB oil palm varieties tenera with 5 maturity level. And next, furthermore, the oil palm FFB image is recorded using a mobile camera with a camera resolution of at least 25 megapixel. The distance from the camera to the FFB object at least 3 meters and maximum 12 meters. To maintain stability in capturing oil palm FFB, we use a tripod. When taking the image, the camera position adjusts so that the FFB surface to, to be recorded is not obstructed by front or other plant parts. Each bun was taken to the laboratory for analyzing the oil content. The test was conducted within 24 hours after the bunch had been harvested. Result and discussion from the graphic. We can see the minimum oil content is founded in FFB with a maturity level of 110 until 130 day after anthesis with a value of 11.50%. And then the quality of oil palm fruit at young up has low quality. This can be seen from the low palm oil. The optimum oil content value is founded in FFB with a maturity level of 171 until 119 day after anthesis, namely 24.44%. Then, and at the 191 until 200 day after anthesis maturity level, the oil content value is reduced by a value of 23.44%. The oil content increase according to the ripeness of the fruit. So, model development use input variable in the form of RGB and their derivative consisting of 26 factor. In the initial stage, all variables are entered into artificial neural network processing. Furthermore, input variables that have a low contribution to the predicted value will be eliminated. This stage will be carried out continuously until a high predictive value is obtained. The models from my research to calibration was 0.6934 and validation R square 0.7211. We conclude the model was considered appropriate since R square value both in calibration and validation were high. The conclusion from my research in this study, the quality parameter of FFB were identified based based on optical properties at 5 levels of fruit maturity. Optical characteristics are observed using a mobile camera and evaluated based on the recorded image. The level of maturity influence the optical properties of the image. The level of ripeness causes change in oil content. The model is developed from the optical properties of recorded FFB image, where these optical properties are used as input variable to artificial neural network. The model successfully predict with square upon calibration was 0.6934, and then validation was 0.7211. Uh, it, it's my present. Thank you for attention. I return time to moderator.
Okay, thank you. That's yeah, you spent 8 minutes, 7, 8 minutes. That's very nice presentation also. Now I will give time for the participants. If you have any question, please just deliver your question directly to the presenters. Anyone?
I already write in the chat room, please.
Okay. Wait, yeah. Okay. There are 4 questions. Maybe you can answer it yeah, a little bit faster. First question is, what kind of a software used for these results? What kind of a software? Number 2, how to transfer the pictures you take from camera to the software? Do you have one picture as a sample? So how many picture you use? And the last one is, what do you want to do to increase the R square of calibrations? Okay, so you can answer these questions.
Okay, thank you for your question. I will to try to answer your question from Hesti Melina. Number 1, what kind of software used for this result? This my research. I use SPSS 2020, and to program to software I use image processing program from my lecture. And then number 2, how to transfer the picture you take from camera to the software. I transferred the picture from camera to the software with call the image to the software with image have wait. Because the image have was saving to computer. So to and then we call to image from Windows with open command. One picture as a sample. And number 3, do you have one picture as a sample? Wait a moment.
Hello, Miss Melidawati. Bu Melidawati.
Yes, sir. At the moment, I want to search, but question for number 3. Do you have one picture as a sample?
Wait a moment. I want to looking for the. Maybe next time you can.
Yeah. Or because now we have limited time. Yeah, maybe after this, yeah, you can send the message privately after this, and then yeah, or you can find the picture now.
Wait a moment. Give me a moment to open from my computer.
Or I think because we don't have a lot of time now, maybe you can just continue to the fourth question. What do you want to increase the, what do you want, or maybe how to increase the R square of calibration?
Running more and needs more time.
To question for number 4, yes, I want to increase the R square of calibration with running again from artificial neural network. But I don't have much time.
Hello?
Yes.
Okay, so you agree that the R square of the calibration is quite low, right?
Sorry, can you repeat
Okay,
again?
so you agree if the value of the R square is quite low?
To
Yeah, I think we can discuss about this later because now we already spent around 15 minutes and we have only 10 minutes per presenters. So please give applause for Ms. Melidawati for the very nice presentation. And
thank you, sir.
yeah, and now we move to the last presenters, I guess. Ms. Suyanti Kasimin, are you here?
I'm here.
Okay, so you have 10 minutes and you need to divide it into 7 to 8 minutes for the presentations and then 2 to 3 minutes for the Q&A. So now you can share your screen and time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Slip. Orang kita nggak slip kan? Kenapa bingung kan? Lagi Zoom tadi, cuma sekarang nggak ada.
Nah, dengar suara saya? Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you for the opportunity, Mr. Arifin Wisaputro. I am Suyanti Kasimin, Wakil of Jakiyah Mujibur Rahman Jaura. I am from Agriculture Faculty Indonesia and Jaura from Agriculture Faculty UGM. My research title is Constraint of Leading Horticulture Aceh Entering the Agribusiness Digital Age. The background of this research, the use of digital information can increase the accessibility of farmer and intermediary trader quickly to market information, production input, consumer trend, technology, and new innovation in ecosystem in agribusiness. But there are some barriers like gap in training, awareness of the benefit of this technology, time and cost, system integration, and software availability. The barrier make difficult for farmers to take the advantage of digital technology when they need it. So the objective of research are see the obstacle that exist in the use of digital technology for the farmer horticultura superior in Aceh and looking for solution in superior horticultura agribusiness in Aceh. The research methods is consists of 6 part. The first research location is Aceh Besar District, Aceh Tengah District, and Benar Meriah Regency. Why I think their location? Because they are the center of horticultura superior in Aceh. The number of research sample was 50 people consisting of 30 farmers and 20 stakeholders. Using of questionnaire and data analysis, seeing the constraint that exist in measurement of the characteristic of actor, characteristic of land, and characteristic of technology. Recommended solution to problem based on suggestion from farmer, community leader, expert, and government official. A result and discussion. The first farming characteristic. In table 1, we can see the characteristic consists of age, education, land set, horticultural land, rangeland, production, and productivity. The sample farmer is chili farmer, potato farmer, and citrus farmer. And the four column I make horti farmer average. We can see the age of average farmer is 45 years, and education 9 years. Land set is they have 1.6 hectare, but the use of horticultural land only 0.78. Why? Because they kekurangan, they kurang modal like that.
Lack of, yes.
Rangeland is expensive. 1 hektar.
Bu Kasimin, Bu Suyanti,
ya.
Dapat dibesarkan tidak layarnya? Di full screen di ini. Kalau memungkinkan. Ya.
So, thank you, sorry. Production, chili farmer 0.83, potato farmer is 6.97, and citrus farmer 0.3, and the average horti is 2.2 ton per hectare. Productivity, we can see only 4.6 ton per hectare. We can compare characteristic of actor, land, and innovation in digital age and today. So I compare digital era condition is need egg farmer young, education high, innovation creative aggressive, productivity required dibutuhkan, only marketing required, and internet utilization required. But the existing current condition is egg relative old, education low passive, and productivity decrease, innovation decrease, productivity not available, HP Android utilization not available, and so on. So we compare that is the gap between the condition need and the current condition. Characteristic property land utilization should 100% but below 100%. Land rental price low but in the current condition high. Land tenure high but the current condition low. Then land tenure status owner but current condition they are rental, menyewa. Land conversion rate is low but in the current condition high. Karakteristik inovasi should modern, but traditional and fund for innovation, available and sufficient but not available. Understanding of technology easy but in current student is difficult. Absorb power of technology high but in current condition is low. The set table I want to make the cost and troubleshooting agribusiness in digital age. The cost of problem I in three part: characteristic of actor, land use, and innovation and technology. And problem solving I made based on the cost. Characteristic of actor, youth are not interested in agribusiness. So what is the problem solving? Market guidance and insurance. Low education, problem solving, educational scholarship, has no innovation, problem solving, socialization, coaching, and innovation application. Increase global temperature, choose a commodity suitable for high temperature and low online marketing access, can problem solving by development and provision of facilities. Low access to computer, soft capital assistance and guidance, dan low access to internet, provision of facilities and assisting with operational costs. For land use, lack of working capital, assistant, the use of zakat maybe, low land ownership, regiment of rental price and land distribution, low land ownership, distribution and development of land, no land grant, low of land tenure for farmer, and there is no control over land conversion, law of restricting the conversion of agriculture land. For technology and innovation, low social economy access, technology dissemination and innovation, low social economy access, funding for innovation and new technology, primary education level, increase applied education, and lower level of education, increase application education. We can see the problem solving of increase of digital aid for farmer.
Bu Suyanti Kasimin, your time is about to finish. Maybe you can make it faster.
Okay. Conclusion and recommendation. Internal constraints are old age, low education, low control of land, and access to working capital and digital technology. External constraints are policies that don't support farmer in increased access to technology, capital, and land tenure. The solution suggest are increase the motivation of young to develop agribusiness, improving education, increase access to land, working capital, and technology, as well as digital technologies. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, so that's the presentation from Ibu Suyanti. Please, if there is question, any question for Bu Suyanti? Bu Suyanti Kasimin. Please. Okay, Bu Suyanti,
Yes.
how did you get the, maybe can you please go to the table 1, 2, and 3? And also research method, please. Okay. Okay, it mentions that the number of research sample was 50 people, consisting of 30 farmers and 20 stakeholders. So in total, there are only, I will say that 30 farmers. 30 farmers is not that lot. And how you make sure that all the farmer really represents the farmers in Aceh? So how did you choose the sample? I will say like that. So maybe you take the farmers from several districts, or something like that.
Yes. I take the farmer of Horticultura Superior. So I choose the region, the center of Horticultura Superior.
From how many districts?
Through district in Aceh, 13.
13. Okay, so you take from 13 districts then.
Yes, 13 district because they are the center of product of Horticultura Superior. The first, I want take 60 people consist 30 farmer and 50 stakeholder.
Okay.
The condition like that, I go to the field visit in June and for 2 weeks, and I think 30 farmer and 20 stakeholder can mewakili.
Okay.
I want take three expert, three pedagang like that. But because the condition, I only take 20 stakeholder.
Okay.
Like that, sir.
Okay. So I'm sure that you take the samples in a very good manner then. Okay, there is another question: how to cope with gaps in training?
What, sir?
How to cope with gaps in training? Ibu bisa lihat di chat room. Bagaimana untuk mengatasi gaps?
Oh yes.
Pada saat proses training ya.
Yes. To cope the training, pada saat training.
Ya.
The training is not only one, but can continue in some of period, and the not only the training we can be the farmer, but access like that, bantuan apa Pak? Akses to teknologi, akses to peralatan, and bantuan like that. So not only training but pendampingan.
Oke. Jadi tidak hanya training tapi juga pendampingan ya Bu ya, seperti itu. Oke, ya. Terima kasih Bu Suyanti Kasimin atas presentasinya yang sangat bagus. Jadi Ibu adalah presenter terakhir sehingga ya menutup presentasi pada sore hari ini. Finally, all the presentation are done. All the presenter did very good job with very interesting topics. And for your information, after this session, prior to the closing ceremony, there will be announcement of the best presenters. So you may be the lucky one I mean the moderator, give you score for several aspects during your presentation. So maybe you will be the best one in this category. So please be there. And on behalf of the organizing committee, I would like to say thank you to all of you here for attending this session. So good evening, everybody, and you can move to the main room after this. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Pak, pergi ke mainnya kayak mana, Pak? Ke main room? Tuh, langsung.
Ibu bisa tekan live room ya?
Live breakout room.
Ya, live room, kemudian pilih live breakout room.
Ya.
Jangan live meeting ya, Bu.
Jangan live meeting, Bu. Ya.
Live room.
Terima kasih, Pak Arifin.
Iya, Ibu.
Terima kasih, Pak Arifin.
Sama-sama. Ya, semuanya bagus-bagus.
Amin, alhamdulillah. Halo, host. Host. Co-host.
Iya, Ibu.
Mau ke ruang utama ya?
Iya, Ibu.
Ya, makasih.
Iya. Sama-sama, Ibu.
Jam 5 tuh. Assalamualaikum, Vira. Belum, nggak tahu caranya. Live kan? Udah, habis itu nggak ada berubah-berubah dia. Nggak tahu caranya nih. Udah saya klik nggak mau berubah. Saya minta. Ya. Bentar ya. Main room. Ini nggak bereaksi dia. Saya klik live room, diem aja dia. Nggak ada keluar. Iya. Ya, kamar aku berantakan. Ya. Hey. Nih. Dah nih.
Coba Ibu tekan chat dulu biar bersih sedikit itunya.
Oh ya, chatnya nih ya.
Kurang ke bawah.
Laptop nih pun dia nih. Laptopnya nih padahal baru nih. Ikut orangnya. Ngomongnya apa tuh Vira? Ngomongnya bahasa Inggrisnya celepotan. Alah, udahlah. Belum. Ini dia aja nggak bisa ditutup. Apa laptop saya ya, hang ya? Nggak reaksi. Saya tekan apapun. Tapi kok saya tekan. Oh, berarti saya minta tolong ini aja supaya disuruh dimasukin itu ya, tinggal klik ya. Minta tolong host. Minta tolong sama hostnya. Iya. Makasih Raya. Udah selesai kan? Promosi online juga. Vira di Banda Aceh sekarang. Oh iya. Kok malu? Kasih tahu lah. Kemarin nggak dikasih tahu. Nggak tahu saya nggak dapet Zoom-nya. Iya. Ya kasih tahu lah. Nanti Ibu bisa ketemu Ibu Amanah, bisa ketemu Ibu apa lagi Ibu Aida. Oh, Pak Dwi itu kawan saya. Satu angkatan dulu kalau kami main sandiwara, si Dewi jadi anak SMP. Anak kecil. Sekarang udah jadi dosen IPB, ya Allah. Ya, makasih Vira. Waalaikumsalam. Assalamualaikum Dek host. Dek, Assalamualaikum Dek Yusril. Dek Yusril.
Iya Ibu.
Saya nggak bisa masuk laptop saya hang, bisa dibantu Dek masuk ke main room.
Tombol live-nya nggak bisa Ibu klik ya?
Saya klik nggak bisa, ini partisipan saya tutup pun nggak bisa. Kayaknya hang ya laptop saya.
Mungkin bisa Ibu minimize kemudian refresh laptopnya Bu. Mungkin.
Oh, ini udah keluar deh.
Iya.
Break room nih saya klik ya.
Iya, klik Bu.
Nggak bisa juga, Allahu Akbar.
Mungkin tunggu hingga detiknya habis, nanti akan otomatis kembali ke main room Bu.
Oh ya. Oh, makasih.
Oke. Mereka nggak menampilkan gambar kita ya?
Dengar Pak suara Bapak. Tuh, Bapak.
Apa nih anti itu? Gimana ya?
Pak Samadi bilang, dengar nggak suara kita? Dengar Pak, saya bilang.
Di anu dia nggak kedengaran.
Bapak kok tadi bagus sekali Pak kasih hadiah untuk presenternya. Pak tiap hari Pak maunya pakai jas kayak gitu Pak.
Guanteng.
Guanteng. Bu Bumi yang bilang ya Pak.
Thank you to the invited guests that have provided us with some very important lessons today. Now we will announce the best presenter. We would like to call Dean of Agriculture Faculty, Professor Dr. Insinyur Samadi, to the podium.
Okay, thank you very much for all the participants. We get the name of the best presenters from the committee for this ICATES, the second international conference, Agriculture, Technology, Engineering, and Environmental Science. So who is the best? The first best presenters is, I will look in, with the ID 26. The name is MD Didarul Islam. He's from Bangladesh. With the score is 95.
Yes.
With the title of the presentation is Removal of Chrome and Other Pollutants from Tannery Wastewater by Moringa stenopela seeds. So this afternoon we have two winners, I mean the two best presenters that sent by the committee. The second best presenter is Rahmayani. The ID is 46. Is from Jambi. Yeah, congratulations. Is with the title of the presentation is Modification of Purple Yam Starch using precipitation method with various solvent ratios and its application for edible films. There's a congratulations for the first and second best presenter for this second ICATES conference held by the Faculty of Agriculture, Syah Kuala University, Universitas Syah Kuala. And what is the committee? I have to hand over for the small gift for the first and second best presenter. I hope that two of them still in our virtual conference this afternoon. Okay, first is MD Didarul Islam is still in our room right now.
Sir, my name is Mimmuh Mahdi and I'm on behalf of my team is present here.
Okay, congratulations. Thank you.
Thank you, sir.
Thank you.
Yeah.
And also from Ibu Rahmayani, are you still in the room? From Jambi. No? Already leave?
Yes, probably, Prof, because we cannot see her ID.
Okay, maybe.
Okay.
Maybe he's not in the room anymore. Okay, I think for the best presenters for this seminar we have already announced, and one more congratulations for the best presenter for this conference. Thank you. I'll back to the MC.
Thank you very much. Yeah, thank you very much, MC, Mr. Juzaili Ridwan, and Miss Anna Misko. Okay, ladies and gentlemen, again, as our appreciation to your important contribution to ICATES 2020, hopefully for the development of sustainable agriculture in Aceh, Indonesia, and worldwide, hereby we would like to find again two lucky draw presenters. I will share my screen.
Bapak bilang yang kecil-kecil itu kok gembung deh, yang nomor lantai 3 itu hari kapan punya? Mana? Di tempat 3 nomor 3. 3 buang. Sudah lama tuh. Bisa. Masih dibuang itu Bapak kan? Ya. Misalnya.
Kalau ada nampak wajah kita.
Okay. Here now I have the lucky wheel.
Pak Yasar, di mana posisi?
We will count from 3 to select the first lucky draw.
Pak Yasar, di mana posisi?
Presenters. Bismillahirrahmanirrahim. 3, 2, 1. No, the selected one was Dr. Ramayanti Bulan. Congratulations. And now we will try to find the next lucky draw presenters. But before, if there is suggestion from Dr. Ikhwana, actually, I delete the name of the college from the Department of Agricultural Engineering, but I missed this name. And then we select this. I don't know if we will.
The right agricultural technique is required to transform natural resources efficiently, effectively, and optimally.
Okay. I mean, should we try again or okay with the first selected one?
Producing alumni that will be able to master their skills in the field of science engineering and apply it to agriculture. The Department of Agricultural Engineering was officially formed on 1997. House Division of Center of Outstanding, Independent, and Innovative Research and Education Development in the field of agriculture.
I'm sorry for my mistake because we have the decision that we will skip the name from our college, and really Dr. Ramayanti Bulan is my college and a part of the committee. So I think we will try again, yeah. The first lucky draw presenters. I'm sorry for this. So I will start again with the first lucky draw presenters. 3, 2, 1.
Besides that, the relevancy, quality, and amount of research activities from students and lecturers alike continue to rise through various programs and collaborations.
Yes, we get it, eh? The first one is Ibu Dr. Chut Nur Ihsan. Congratulations. And now I will select the second one. Be ready. Or we will also delete the winner name first to avoid.
This technology is important used to quickly evaluate and predict quality and chemical parameter of foods, agricultural products, and livestock.
Udah.
agricultural engineering will not stop here. There are still many creations and innovations that are being developed to be applied in the future. As long as the problems in agricultural engineering still exist, the Department of Agricultural Engineering will keep on innovating. Growing, the need for agriculture. Unfortunately, the land available for agriculture is also decreasing. Provide a solution for all of these problems. Agricultural engineering of the University of Iowa is committed to producing alumni that will be able to master their skills in the field of science engineering and apply it to agriculture. Agricultural engineering on January 8, 1997. It has the vision of
Okay, thank you very much for the MC. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, ladies and gentlemen. First of all, on behalf of the Faculty of Agriculture, we would like to thanks for all of you to join with our second international conference on agriculture, technology, engineering, and environmental science, or ICATES, that start from this morning and right now already 5:45 in Indonesian time, Western part. Maybe some of you in middle part of Indonesia or eastern part of Indonesia 2 hours earlier, 1 or 2 hours earlier than us from Western. And also maybe some of you not in Indonesia and some part of the world is we have different time. I think right now you must be very tired. You already start from this morning in front of computer, in front of laptop to follow our seminars for 1 day seminars. This we appreciate for all of you. What I heard from the committee that this conference is very successful, attended by 300 participants in the morning, but in the afternoon, it about 200, more than 200. This is a very big event, we think. And as we know that this is our first experience also to conduct the international virtual conference. So we are really concerned before about the internet connection, about the electricity, but fortunately we can conduct this international conference very successfully. So we really appreciate for the host of this conference is agriculture, engineering, and also in conjunction with the second international seminar and sustainable construction, University Malaysia, Pahang, and also the 4th national conference, Wind and Earthquake Engineering University, Pahang, Malaysia, and also the second South Aceh International Conference on Engineering and Technology, Polytechnic Aceh Selatan. So maybe this is quite different from before due to pandemic COVID-19. So we cannot conduct this international conference offline. So we have to do this by virtual conference. So in this a very good moment, we would like also thanks to the Rector of Universitas Syah Kuala, Professor Dr. Samsul Rijal, And also for our keynote speaker for this conference, Professor Dr. Jens Wegener, Head of Institute Application, Techniques, and Plant Protection, Julius Institute Braunschweig, Germany, and also Dr. Amru Babikar Hassan El Tayeb, Environmental Studies, King Saud University, and also Dr. Rernat Sahril Anwar Bahari, Faculty of Applied Science, University Technology Mara, Malaysia, and also our colleague is Professor Dr. Lilit Sutiarso, Engineering Biosystem Engineering Department, Universitas Gajah Mada. And also our honor to the head of Agriculture Engineering Department, Faculty Universitas Syah Kuala, and also the chairwoman for this conference, and of course also all the participants that join for this conference. That I got information for the committee is about 300 participants from over the world. This is a really, really big event that we are really appreciate about this. And this conference is very important with the topic about emerging novel research in agriculture, engineering, and environmental science facing the era of revolution industry 4.0. I think with this conference, a lot of recommendation that we can improve our agriculture system. So as we know that the population right now in the world is 7 billion, it will be increased for the next 10 years, it will be 9 million. So how do we feed the people? So before we know that green revolution. So right now there is many systems that maybe we already heard that from many keynote speakers today. So agriculture, we have to base the sustainable farming, and then smart farming, and we have also big data, artificial intelligence, that we can improve the productivity. So like one of the speakers from Germany said, that how we make the high input so we can produce with the low input, so with this farming, so we can feed the people in the world, will be increased for the next 10 years. And luckily from our university, Syah Kuala University, we have 2 grants from Erasmus Plus that related to Industrial Revolution 4.0. We have to create magister program for artificial intelligence and big data, big system. And so maybe we from agriculture, we have to take part for this part. So very this good moment. One more, I will appreciate also from the Agriculture Engineering Department, all the committee, the chairwoman, Dr. Ihwana, they already work hard with all the team to success for this conference. Finally, we hope this conference is not the end. So we hope we will conduct the next conference for the next year, 2020, with the 3rd international conference. We hope that pandemic COVID-19 will end, so you can visit Banda Aceh and you can visit our university to conduct this conference for the next year. Thank you very much for all participants, and congratulations for the committee. They have already success to conduct this conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
That the knowledge gained during development will prove useful in the future in our field of study and research.
We extend our sincere gratitude to everyone.
Thank you for your participation and contribution, and see you all at the next conference.
Let's go. Nggak tampil di room.
Sayonara, sayonara, sampai berjumpa. sayonara sampai berjumpa pula. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Sayonara, sayonara sampai berjumpa pula. Sayonara, sayonara sampai berjumpa pula. Buat apa susah, buat apa susah. Sayonara, sayonara sampai berjumpa pula. Sayonara, sayonara sampai berjumpa pula. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Buat apa susah, buat sayonara, sayonara sampai berjumpa pula. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Sayonara, sayonara sampai berjumpa pula. Sayonara, sayonara sampai berjumpa pula. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Sayonara, sayonara sampai berjumpa pula. Sayonara, sayonara sampai berjumpa pula. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Buat apa susah, buat apa susah, susah itu tak ada gunanya. Kalau kau suka hati, mari kita bersama. Kalau kau suka hati, injak bumi. Ayo direktur, direktur.